Namaskar. Good morning, everyone, and welcome to the webinar on Statistics and Data Analysis, organized by the Department of Statistics, Gargaon College. I am Dr. Ranjana Gogoi, Head of the Department of Statistics, Gargaon College. I feel very happy and honored for overwhelming response from a huge number of participants who are connecting today with us to attend this webinar. Today, the 29th June of 2020 is the 14th National Statistics Day, which is celebrated every year on this day in India to create public awareness among the people about the importance of statistics in daily life and in the process of planning and development of our country. In each year, Government of India adopted some themes to observe the National Statistics Day, and this year, the Government of India have adopted two themes from the Sustainable Development Goal adopted by United Nations Development Program. The first one is to ensure healthy lives and promote well-being for all at all ages. And the second one is to achieve gender equality and empower all women and girls. National Statistics Day is the acknowledgement of renowned statistician, Professor Prashanta Chandra Mahalnobis, in recognition for his invaluable contribution in the field of statistics on his birthday. Today is the 127th birth anniversary of Professor Prashanta Chandra Mahalnobis, the father of Indian statistics and the founder of the premier institution of India, the Indian Statistical Institute, situated at Kolkata. For today's webinar, we have with us Honorable Principal, Gargaon College, Dr. Habbahasi Mohanto, who will officially inaugurate this webinar in a short while. We are connected with respected Professor JITEN Hazarika, Head of the Department of Statistics, DIBRUGARH University, who will deliver a lecture on statistics, what, why, where, and how. Dr. Manas Pratim BARMAN, Associate Professor of Statistics, DIBRUGARH University, is also online from DIBRUGARH, who will deliver a lecture on statistical analysis using software and especially on SPSS. So, welcome all of you again to the webinar on statistics and data analysis, and I request Honorable Principal, Gargaon College, Dr. Habbahasi Mohanto, to deliver his inaugural speech. Over to Dr. Habbahasi Mohanto.
Very good morning to you all. Thank you, Dr. Ranjana Gogoi, Head of the Department of Statistics, Gargaon College. On this very auspicious day, you have already listened to Dr. Ranjana Gogoi. She has beautifully explained the significance of this day, this 14th National Statistics Day. And the Department of Statistics, Gargaon College, has been organizing this webinar on statistics and data analysis on the occasion of 14th National Statistics Day. And I would like to welcome you all, our honorable resource persons, teaching faculty, teaching members, and research scholars, and also our dear our students to this webinar that has been organized by our Department of Statistics of Gargaon College. Dr. Ranjana Gogoi has already beautifully explained the significance of the day. Today is 29 June. This has been observed as National Statistics Day since 2007 to celebrate the birthday of Professor Prashanta Chandra Mahalnobis, who is regarded as the father of Indian statistics. He was a renowned scientist and statistician. Professor Mahalnabis was the member of the first Planning Commission of Independent India, and he also founded the Indian Statistical Institute. And the aim of observing the National Statistics Day is to create public awareness about the importance of data in socio-economic planning and policy formulation. I must appreciate the endeavor of the Department of Statistics of Gargaon College. Especially, I would like to thank Dr. Ranjana Gogoi for her able leadership and her entire team for organizing such a beautiful webinar on the occasion of 14th National Statistics Day. I would like to offer my sincere gratitude to our resource persons, Professor JITEN Hazarika, head of the Department of Statistics, DIBRUGARH University. He is a known educationist of Assam, and he is also associated with various policy formulations of our DIBRUGARH University. And another resource person, he is also from DIBRUGARH University, Dr. Protim Barman, Associate Professor in the Department of Statistics, DIBRUGARH University. I would like to welcome both these renowned and learned resource person to our webinar. I hope their deliberations, their speech, their presentation will definitely help both the teachers and the students a lot. I'm also very much encouraged, and we are really encouraged to see the overwhelming participation in the webinar. More than 500 participants have participated in this particular webinar, and it is really a positive sign in the time of lockdown during this spread of COVID-19. This overwhelming response would definitely encourage us to do something in the field of academia, and hope this webinar would be a grand success, and both the teachers and students would be highly benefited by this webinar. I would like to welcome you all again, and I declare the webinar open officially. Thank you. Thank you so much.
Thank you, sir. Now I request Professor JITEN Hazarika, head of the Department of Statistics, DIBRUGARH University, to deliver his lecture on the statistics, what, who, where, and how. Over to Professor JITEN Hazarika.
Am I audible?
Yes. Yes, sir. You
Okay.
can continue.
Okay. Good morning, one and all. Dr. Abhokasi Mohandra, Principal, Gargaon College. Dr. Ranjana Gogoi, Head of the Department of Statistics and Coordinator, was our student, Ms. Bornali Dutta, and my dear participants. Actually, today is the birthday of Professor P.C. Mahalnabis, who is popularly known as among staff as PCM. PCM does not imply physics, chemistry, mathematics. Actually, he was a man of physics, chemistry, and mathematics originally. But he is popularly known as PCM among staff due to his professorship in the Department of Physics. He started his service in the Presidency College as a professor of physics. But he has motivated to the discipline of statistics. Today, as today is the 27th birthday of Professor P.C. Mahalnabis, so we are going to consider mainly importance of data, from which he motivated to use statistics, particularly in second 5-year plan, and from anthropometric studies particularly using different tools of multivariate analysis. Actually, P.C. Mahalanobis was the pioneer in the application in statistical techniques in practical problems and architect of a second 5-year plan. Today, at the very beginning, I congratulate Department of Statistics, Gargaon College in particular, and college authority, particularly principal of our college. He is a dynamic person, I know him. And I think this is the first webinar, or in other sense, online seminar organized by, forget about the online, in large scale mode. This is the first seminars organized by the colleges of DIBRUGARH University on the occasion of birthday of Professor P.C. Mahalanobis. No doubt, earlier also we organized different functions, different programs, but it is in a compact form. Now let us come to the, as time is limited, let us come to the today's topic of discussion. Statistics as a discipline. What is statistics? Why statistics? And where and how statistics? Before going to what is statistics, why statistics, how statistics, where statistics, let us start with a quote of Stephen R. Covey. Like a match, it can destroy a building or give light to a dark place. It's your choice. Statistics is like this type of subject. You can use like a match to give light on a dark place, or you can destroy a building. That is called destroy a building, called misuse of statistics. Other one is actual use of statistics. I will come this type of examples later on, later part of this presentation. Now question is, let us come to what is statistics. Statistics is like other disciplines. I have put questions, yes or no. If anybody can say as yes, I will discuss later on with them. He or she has to justify how it is yes. I am in favor of no. Statistics is not like other disciplines. I am going to say that it is no. Why? Question is why. Let us come to the Dr. APJ Abdul Kalam. What is a discipline? Thinking is progress. Non-thinking is stagnation in the individual, the organization, and the country. Thinking leads to action. Knowledge without action is useless and irrelevant. Knowledge with action brings prosperity. This is the quote from APJ Abdul Kalam. Likewise, thinking leads to our ideas. But a discipline is the accumulation of what? Ideas. Small minds discusses people. Average mind discusses events. Great minds discusses ideas. So discipline is the accumulation of great minds' ideas. It is nothing but accumulation of great minds' ideas. This is called discipline. Now, to accumulate ideas, each of these discipline has subject matter of its own, which are solved by using the knowledge of the subject. Statistics is not like the sub-disciplines of basic sciences, mathematics, physics, chemistry, biology, or social sciences. There is not a problem, single problem like statistical problem, which statistics are supposed to solve. We cannot get a problem that this is a problem of statistics. No, we are going to use our tools, our techniques, some techniques according to demand of the society, according to demand of the biologists, according to demand of the sociologists, according to demand of the medical persons. So statistics is used to solve problem in other disciplines, and appropriate methodology is developed for any given situation. The basic problem of statistics is viewed as quantification of uncertainty. Statistics is, I will do the definition. Statistics is viewed as quantification of uncertainty. That word is very much important in statistics, which may be considered as the subject matter of the statistics for study and research. Again, technology or art. Statistics can play as a science. It may be a technology, it may be an art. Sometimes, like in art, we have to face some controversy regarding statistical theories. So from that point of view, it is an art. But in some cases, we are going to provide some technologies, statistical technologies. For example, in industry, statistical quality control. We need a quality product. In case of quality, in this situation, we are going to use some statistical tools. It is under the statistical quality control purview. And this is a technology. We provide some techniques, technologies to the industries. Again, we have developed some theories also, like other science disciplines. So from that point of view, statistics is science. So statistics is a science, statistics is a technology, statistics is sometimes art. Now, statistician, and so no field of data, as I have told, that it is not like the other disciplines that some statistical problems are there. As statisticians have no field of data of their own, they cannot work without others. That is the practical situation. But other scientists started working without statisticians. As time passes, they also could not work without the help of statisticians. Very good. In the long run, statisticians help prove to be indispensable what has been proven and become noticeable and conspicuous in today's scientific investigations, including medical sciences. In developing countries, there is a huge communication gap between statisticians and scientists. Two groups lack a common database. Engineers and other scientists know little of statistical methods. Again, statisticians know less engineering, medical, physical, and social sciences. We do not know what is the criminology, what is the crime, what is this. But we are going to use some statistical tools, knowing or unknowing the background of the study, without taking help of the persons from sociology or persons from political science. We are going to use our statistics. Similarly, some engineers, without knowing some scientists, other scientists, without knowing the background of the statistics, whether it is applicable in this place, particular place or not, without knowing that if data are there, software are there, they are going to use the statistics. This is the communication gap between statistics and other scientists, particularly in our developing countries, not in developed countries. Because in our developing countries, development of statistics is also left due to Professor P.C. Mohalnovich, this development coming due to Indian Statistical Institute, and Indian Statistical Institute was also under a Society Act earlier. Then I think in the year declared as Institute of National Importance and empowered to award degree by an act of the Parliament in 1959. So from 1959 onwards, Indian Statistical Institute, it is in Kolkata, and different branches are there in Bangalore and others. That Indian Statistical Institute is due to P.C. Mohalnovich, and they started first B-Stat, M-Stat, and other courses like diploma courses in proper way. Earlier, it was as a somebody says that this is the branch of mathematics. So each group means statistician, politician, sociology persons, or medical persons, biologists, and psychometrician. Each group uses its own jargon and hence cannot begin to communicate. Due to lack of knowledge, many even do not recognize the need of statistics. There is little interdisciplinary and cross-disciplinary interface between statisticians and scientists, industry personnel, etc. So what is the remedy? We have to give remedy. Being an academician, we should provide some remedy for that. Statistician talking to other statisticians and statisticians citing other statisticians will not work in that age of inter and cross-disciplinary, social, physical, and medical phenomena. Teaching people how to use statistics to solve problems rather than teaching that to a statistician would be. আমি বিভিন্ন ক্ষেত্ৰত আমি কি কওঁ statistician হোৱাবলৈ গুৰুত্ব দিওঁ তাতে আমি statistics শিকাব লাগে statistician বনাবলৈ যাওঁ আমি অসমীয়াত কওঁ যে বনাবলৈ যাওঁ statistician বনাব নালাগে statistics শিকাব লাগে so what is remedy again to educate academic statistician on the nature and language of physical, social, engineering sciences and area of application may be solved. Statisticians should act as a colleague in problem formulating and solving. Generally, when a person from Department of Economics, when a person from Department of Political Science, Department of Sociology come to meet us, we are going to show our expertise. We are the expert. We are statistician. So I have no time. Now I have no time. That type of comment generally we are going to give. Same is the case for economist person also. Sometimes we are going to ask about the problems of particular problems regarding economics. We have no idea the details about the economic planning or something. Then they are going to show, I am the economist. Why? A colleague in problem formulating and solving. Same is the case for not only statistician, it should be for the economists, it should be for the doctors, physical scientists, for one to all. So, what is the definition of statistics? From the above discussion, since the beginning of the history of mankind, man has been confronted with the problem of deciding a course of action that could be the place for him under the circumstances. This process of making judgment according to various criteria is known as the science of decision making. But every science are going to take decision. Every science has decision. They are going to take decision. So how statistics is different from the other disciplines? This is the question. But statistics is the science of decision making under uncertainty. We add the word uncertainty. Now some mathematical tools are there in fuzzy sets and fuzzy these things. They are also going to use the word uncertainty. But originally it was in statistics. we are going to minimize the uncertainty. Now you know everywhere uncertainty is there. So we are going to minimize uncertainty. So from that point of view, statistics is an important discipline because statistics is going to minimize uncertainty. It is the science of decision making under uncertainty. Now the question arises. Sometimes I will take some story also, our day-to-day life story. I mean, যিবিলাক সাধাৰণতে আমি সদায় পাই থাকো তেনেকুৱা when we are going to take decision, there may be two options. One is right decision, other may be wrong decision. Sometimes right may be wrong, wrong may be right due to misunderstanding or misinterpretation or misuse of statistical. Now, decision is yours, whether it is right or wrong. Let us come to a story. The old man could answer any question that is given to him. Two of the local boys thought, Manujan mane আৰু লোকেল বয় ভাবিলে যে তেওঁক কেনেকৈ মূৰ্খ বনাব পৰা যায় আজি তেওঁক মূৰ্খ বনোৱা so they caught a small bird and hid it for decisions. One of the boys held the little bird in his hands and asked the old man if the bird was dead or alive. চৰাইটো জীয়াই আছে নে হাতত লৈ পেলাই দেখুৱালে চৰাইটো এনেকৈ লৈ হাতত দেখুৱালে এটা সৰু অকমানি পোৱালি চৰাই এটা দেখালে যে এই চৰাইটো জীয়াই আছে নে মৰি আছে কিন্তু তেওঁ মূৰ্খ বনাব নোৱাৰিলে তেওঁ উত্তৰটো কেনেকৈ without hesitation if I say you will close your hands and cast it to death. If I say the bird is dead, you will open your, like this slide, you will open your hands and the bird will fly. So on, in your hands, you hold the power of life and death. Decision is yours. You have to take that decision. So sometimes we are going to say our, these are some statistical results in like in election opinion poll. আমি কেতিয়াবা কওঁ ষ্টেটিষ্টিক্সে এইটো পৰীক্ষাংশিকা আছিলে ভুল হ'বও পাৰে ভুল হোৱাটো স্বাভাৱিক এই ডিচিশ্যন লওঁতে এই ডিচিশ্যন লোৱা পাৱাৰটো সেই ষ্টেটিষ্টিচিয়ানজনৰ বা সেই অৰ্গেনাইজেশ্যনটোৰ আছে সেই অৰ্গেনাইজেশ্যনটোৱে ভালদৰে আগবাঢ়িছিলে নে নাই সেই কথাটো আচল প্ৰশ্ন ডিচিশ্যনটো লোৱাটো লাইনটো ঠিককৈ আগবাঢ়ি গৈছিলে নে নাই কিন্তু তাৰ কাৰণে ছাবজেক্টটো কিন্তু দোষী নহয় ডিচিশ্যন বিভিন্ন কাইণ্ডৰ হ'ব পাৰে decision whether type buy or not buy. This is a qualitative characteristics. You can purchase an item or you cannot purchase an item or you may not purchase an item. Then this type of data we have to deal with statistical techniques. We have to convert it to the coded one by one suppose not by decision whether type that is any one of the two. Or decisions may be which you have many options. You have to take one. In this case, also qualitative data. You can go for BSNL, you can go for Airtel, you can purchase for Jio, you can put up on from any company you can take. Choice is yours. Similarly, sometimes contingent decision on conditional. Buy versus right price. If you are agree, you have enough money, you can go for purchase. Or if you are somehow you are satisfied, then you are going to purchase. These are conditional. If this happen, then I will take this one. So these type of decisions are there. The statisticians are to deal with this type of decision making problem. Other subjects also there, but how this is different, I am going to show you. Now, in day-to-day life states in take decision in every subject, in every discipline, we are going to take some decision. And in research purpose, we take some hypothesis. Hypothesis, how that hypothesis is arrived? In our science case, generally we say, instead of hypothesis, we can say selection of problems. But that problem, based on that problems, we are going to take hypothesis. In social science also same thing. But a recognition of need, our provision থাকিব লাগিব তেতিয়াহে আমি কাম কৰিম। হয় কেতিয়াবা আমাৰ PhD ডিগ্ৰী হ'বৰ কাৰণেও আমি কিছুমান কাম কৰোঁ, সব প্ৰয়োজনৰ কাৰণে নকৰোঁ, কিছুমান থিওৰিটিকেল কাম কৰি থওঁ যিবিলাকৰ কোনো কাম নহয় কেতিয়াও প্ৰয়োজন নহয়। কিন্তু সাধাৰণতে আমি কি need থিওৰিটিকেল কামটো নিডটো লাগিব, এইজনে এইটো কৰিছিলে এইটো কৰিলে কি হয়। গতিকে that means a dissatisfaction within the oneself or a void or need. That means selection of problems. This is the first step in taking decision. Then second step is a long one, a strategy to change, to fill the void or need. How to take, that means how to take decision. Different steps, different strategy, different tools you have to go. In statistics, you know which test, t-test, chi-square test, which test is applicable in which place. You have to take strategy. This is an important part. Step 2 is a very important one. Number 3, a conscious dedication to that decision. That is implementation stage. In implementation stage, it is not in our hand, because sometimes completing a project, we provide some result to the government or to some organization, public, they are not going to implement it. What to do now? We have no hand on that part. But up to the suggestion, up to that program, we can go for. Up to that decision, we can go for. What should be we should implement? We can decide up to that. Implementation stage is not in our hand. Now, question is how to take decision at step 2. Step 2, again, you come to our day-to-day life, some simple example. Simple retire hobo সময়ত senior join কৰিছিলে senior officer এজন মানে তেওঁ retire হ'ব বিচাৰে তেওঁ successful মানে senior officer আছে আপুনি সঁচাকৈ বৰ successful আপোনাৰ পৰা বিচাৰো মই success হ'বলৈ হ'লে কেনেকৈ আগবাঢ়িম automatically senior officer say that right decision. You take right decision. Only 2 words, right decision. And again ask, right decision. Moi arambo korimhe kamato moi right decision to keneke lo. Prothome মোৰ decision to right hobo ne nohobo moi keneke জানো? Again one experience. But again ask. Experience. He again replied with 2 words, wrong decision. That means he is going to say, you take decision, it may will gather experience. In that experience, you may want that right. Like the same, like our hypothesis testing, we assume there is no significant difference between the performance of results of 2 schools. দুখন স্কুলৰ মানে পারফরম্যান্সৰ ওপৰত কোনো পাৰ্থক্য নাই. We are going to like that. Ultimately, that decision may be wrong. We are going to assume that কোনো candidate আমি দেখিলে নহয় এইটো আমাৰ ডিসিশনটো ভুল আছে হ'ব পাৰে. How to take decision? If that provisional decision is, then you can go for success. If decision is wrong, then you can get experience. Then you again move to the decision. Provisional. Take a decision. From the experience, you have gathered some knowledge that this is the way, this is the way, this is the way, these way are correct, and these are the way we have committed this. So again, you take this. Then again, it may be wrong or right. So this is the flow charts regarding taking decision. This is our other subject also. In all subjects, we are going to take some decision that will be provisional. Then that provisional decision will be wrong. Right. If right, then this is success. You go to take hard decision. আমাৰ কিছুমান ক্ষেত্ৰত দেখা যায় এজন মানুহে কাম এটা কৰিলে এফিচিয়েন্ট কিবা দিয়া যে ইমানখিনি কাম কৰিলে আপুনি বেলেগ ধৰণে চাওকচোন আপোনাৰ কি প্ৰব্লেম সেইটো নহয় আমি যদি কিবা বহুত কিবা দিব পাৰো তেতিয়া ক্ৰেডিট আৰু যদি বহুত কাম কৰো কিবা কাৰণত ফেইলাৰ হৈ যায় সেইটো নালাগে experience by it may be organization. From that experience, he can go for that. Again, to take decision. If one and one again wrong decision, then he may not be a good researcher. So, we are not going to take any decision. We are idle. In many cases, আমি কোনো সিদ্ধান্ত নলয় এইবোৰ কৰিলে নেকি মই পাছ কৰি এনেকুৱা মই পাছ কৰিলো মই ষ্টেটিষ্টিক্সৰ নহ'লে আৰু মই কি এতিয়া হেৰি হ'বলৈ যাম নেকি এনেকুৱা কোনো সিদ্ধান্ত নলয় ইনডিচিশ্যন ইজ দ্য থিপ অফ অপৰচুনিটি ওচৰলৈ অহা সুযোগটোৰ মানে এটা সুযোগটোক চোৰ কৰা হৈছে যদি আপুনি কোনো ডিচিশ্যন গতিকে তেনেকুৱা ষ্টৰী আছে গ্ৰেণ্ডমাদাৰ এণ্ড গ্ৰেণ্ডছন জোতা কিনিবলৈ গৈছিলে তেনেকুৱা ধৰণৰ কাহিনী আছে সেইখিনি এজ টাইম ডু নট পাৰমিট আই ডোন্ট টেক ইট নাও again the Chandra Mahanas why he motivated to that the very easy way you know all of you there, you will agree, I think, with me. Success is directly proportional to labor. Anybody says, if you work hard, then you will get all of it. Similarly, success is proportional to IQ, intelligent question. IQ means mental age divided by chronological age. Mental age calculation is a part of psychometry, not in our head. We have to take help of psychometry so that psychology person should not show expertise. They should work as colleagues. Then we know. So IQ in question and P again it is the educational method. Perceive hardness, so we are agreed with success is proportional to labor, success is proportional to intelligent question, success is concept we know mathematics. So success is equal to what? Clip. C-L-I-P. C means clip. C means constant. So clip to success equal to proportional constant. Mathematicians say like this. But what happened? Physician also like that. Person. Why statistics? proportion of labor is not same as proportion of intelligent person, proportion of variance. We instead of that, C into L to the power alpha 1, I to the power alpha 2, P to the power alpha 3, and E to the power U. What is this? E to the power is that is random part. That part is not in the mathematical. And our going then we have taken the logarithm of this base E. Then what happened? This is a simple. I have written like y equal to alpha naught plus alpha 1 x 1 plus x plus. This is a multiplication model, and this is called statistics. From this, it is clear. Not only labor, not only proportional, not only some other variables that may work in our access, that be environment and other things. That everything are included in the random part. If that part is very negligible, then we can use this for other we cannot do. So this is the statistician. First one is mathematician. This one is the mathematician. Here S equal to C L I P. We are going to use S equal to C into L to the power alpha 1 plus I to the power alpha to the power alpha Y. So why statistics? Why statistics? I have in the originally in the title I have given why statistics. This is the practical problem. This is the real life situation where we have to use this type of model. So statistics is different from mathematics. From this example, it is clear that statistics and mathematics are not same, but mathematics is the language of. Without knowing mathematics, without knowing mathematical tools, theorems, everything, and we cannot use statistics in our day. Sometimes just knowing that part we can use due to development of statistical software. But which model is to be used, which one is correct, which one is wrong, model jote tote jikonu model ব্যবহার কৰি দিব নহয় এনেকুৱা use statistics. Now statistics where মোৰ প্ৰশ্ন হল ক'ত statistics নাই ৰাতিপুৱা বাতৰি কাগজখন মেলিলি statistics. At least what type of statistics? Descriptive statistics. We are going to describe the situation using some diagrams, using some simple average or this at COVID pandemic. Again and again, we are using rates and ratios, averages, these things. These are nothing but statistics. But in many cases, we have noticed that mistakenly use their statistics. But anyway, they are using statistics. When you are going to purchasing of groceries from the market, you have taken sample cards. From the rice bag, you take a part, that part. If it is not actually statistical sample, then you may in a loss. অৱস্থা বেয়া হ'ব পাৰে কেতিয়াবা আমি চাউলৰ বেগৰ কি কৰোঁ আৰম্ভণিৰ পৰা চাউল চাই ঘৰত ডাঙৰ কিবা উৎসৱ থাকে চাউলৰ গোটেই বেগটো উঠাই দিওঁ তলত কিন্তু চাউল পচা চাউল নাই গতিকে কি কৰিব লাগে আমি ওপৰৰ পৰা ল'ব লাগে মাজৰ পৰা ল'ব লাগে তলৰ পৰা ল'ব লাগে সেইটো হ'ল ৰেণ্ডম চেম্পল গতিকে ষ্টেটিষ্টিক্সৰ মিছ ইউজৰ কাৰণে চাউলৰ বেগটো বেয়া বেগটো প্ৰপাৰ ইউজ হ'লে নাযায় প্ৰপাৰ ইউজ হ'লে ৰেণ্ডম চেম্পল ল'ব লাগিব চাউলটো মুখৰ পৰা চাই পেলাই কেইটামান ধুনীয়া চাউল চাই পেলাই আমি চাউলৰ বেগটো কিনি আনিলোঁ এইটোৱে হ'ল আমি যেতিয়া ডে টু ডে লাইফত আমি ইউজ কৰি তাতও আমি ডে টু ডে লাইফত এতিয়া মই যিকেইটা ইউজ কৰি আছোঁ মই কথা কওঁতে যিকেইটা ব্যৱহাৰ কৰি আছোঁ সেইখিনি আমাৰ অডিয়েঞ্চে চাই আছে মই হাত জোকাৰি থাকোঁ এইটো এটা মোৰ মুদ্ৰা দোষ কোনোবাই কয় দিছ ইজ অলছ' ইম্পৰ্টেণ্ট ফ'ল' মি এম আই কাৰেক্ট নাম্বাৰ 1 নাম্বাৰ 2 বৰাক ব্ৰহ্মপুত্ৰ নিমিত্তে এনেকুৱা ধৰণৰ শব্দ কিছুমান আমি with due respect to that all parts আমি যদি এটা দিনত এজন মানুহে তেনেকুৱা শব্দ বা এটা কেনেকুৱা বাক্য কোনটো বাক্য কিমান বাৰ বেছিটো হেতুই জানো মড ভ্যালু নহয় আমি যে কম মিন মিডিয়ান মড দা frequency highest frequency নহয় জানো the value of the variable গতিকে ইয়াত ভেৰিয়েবল হ'ল তো কথা কৈ থকা হেতুই ভেৰিয়েবল ইয়াত কোনোবাই নাম্বাৰ 1 নাম্বাৰ 2 নাম্বাৰ 3 নাম্বাৰ 10 পাইগে কিন্তু 1 2 3 কিটাকে কৈ থাকে নকয়নে গতিকে সেইবিলাক হ'ল সেইবিলাক মানুহৰ এটা মড ভ্যালু হেতু ইউজ কৰিবই না তেওঁ শব্দত বাক্য knowing or unknowing we are using statistics in day to day life anthropometric analysis actually preaching Mahalnobi's development on statistics and anthropometric analysis mainly body mass index এজন মানুহ এতিয়া মই মোৰ ফটো যিমান আছে হাইট মই এতিয়া বহি থাকোতে মই যিমান হৈ আছো আন এজন মোৰ খতি একে সমান ওখ হয়তো মোৰ কমিউনিটিৰ নহব পাৰে বেলেগ কমিউনিটি কি বহি থাকে কম বেছি similar nasal height nasal part also some name temperature I don't know similarly sepal length these type of measurements are there in the case of multivariate analysis because আমি লাগে আর তার কারণে আমাক দুটা গ্রুপ লাগে আমি ক্লাসিফিকেশন কৰিব পাৰো এটো কোন গ্রুপত পৰে এটো কোন গ্রুপত পৰে সো anthropometric analysis econometric analysis you know econometrics is the amalgam of mathematics statistics and economy economics plus mathematics mathematical economy mathematical economy tar result দিয়ে কিন্তু তার ভ্যালিডিটি আছে না নাই আমি কি করো statistics or inference or test করি তাক establish করো ultimately develop economy mathematical analysis আমি যেতিয়া when we are going to go for forecasting now you have seen regarding weather forecasting these are almost correct now almost correct earlier it was not correct now correct due to development of sophisticated statistical tools as well as statistical software now we are in a position to analyze huge number of data earlier it is not possible there is a part of big data analysis so methodological analysis operation research in operation research is nothing but the optimization we are going to optimize but I am at ki lage profit beshi lage kharos technically PC Mahalnobi আমি যেটো নদী বান্ধৰ আইডিয়া কৈ আছো নদী বান্ধ তেৱেই নদী বান্ধ কৰিছে আৰু ওয়েস্ট বেংগলৰ নৈ তাত কেনেকে বানপানী ৰখাব পৰা যায় ঠিক তেনেকৈ কেনেকে পাৱাৰ জেনাৰেট কৰিব প্ৰথম অপাৰেশন ৰিসাৰ্চ টেকনিক এপ্লাই কৰি উইথ দা হেল্প অফ statistical distribution কৰিছিলে operations is a problem আছে transportation problem there are different problems are there educational research everywhere statistics is there and medical science biological research are completely nowadays depends on but in this situation statistical techniques as well as theoretical relevance both are important demographic analysis you know and planning second 5-year plan starting from second 5-year plan statistical tools have been using this is due to PC Mahalnobi first he has introduced in concept of modeling concept of sampling concept of modeling in case of planning then others is factile graphical analysis we can compare two sets of data using graphical with the help of order statistics order statistics you know order is from large or small in small and large scales are good industries survey you know pilot survey you know pilot survey questionnaire before survey we are tested with a small sample এখন কোৱেশ্যনাৰি কিছুমান ৰিসাৰ্চ কামত আমি ব্যৱহাৰ কৰিবলৈ হলে এটা লাৰ্জ সাৰ্ভে কৰিবলৈ হলে আমি সৰু সৰু এটা স্যাম্পল লৈ আমি তাত কামখিনি কৰি ভাল ৰিলায়েবিলিটি ভ্যালিডিটি আমি টেস্ট কৰা হয় এই ফৰ্ম কৰা সাৰ্ভেটো হয় pilot this is it was due to Professor P.C. Mahalnavis. There is no earlier there was no concept of pilot survey. Due to Professor Mahalnavis, pilot survey is come. And language studies. Suppose some articles are missing. One article is from suppose Professor Lila Gogoi, other one is from other person, other is from other person. All are mixed up. Then we can discriminate. We can classify. We can classify that this article may be of this one. All these article may be of. Some errors may be there. Errors measurement also done by the PC Mahalnavis. And we error allow up to 5%. In day-to-day life, 5% is, I think, it is optimal. Then language studies also anyway. Now, statistics last part. Basic requirement to take decision. Basic requirement to take decision is what? Information. Without information, how to take that problem? So information is we say that is called data. Data are the basic inputs to any decision making process. Any record, descriptive or symbolic representation of an attribute, event or process may constitute data. Data is or classified into categories that are numerically coded. Appropriate use of statistical procedure requires that we understand the data. And now data may be classified with the on the basis of different characteristics in different ways. Again, these classifications are not mutually exclusive. Not mutually exclusive. Data source of collection. If I have collected for my purpose, this is primary. You have collected for my purpose, I am going to use. Anyway, I have not involved in earlier your study, then this is secondary for me. Census data, other data we have not collected, we are using. This is secondary data. These are familiar for all of you, primary data and secondary data. Not only primary data and secondary data, in statistics, different types of data are there. Qualitative or categorical. Categorical data analysis, some special techniques are there. Categorical data, it is based on that type. Qualitative, categorical data, generally we use chi-square test of dependence of attribute, chi-square test. Chi-square, and we use one thing, odds ratio. Odd and odds ratio we are using. And mental Hansel test. And different tools are there. That tools, if I consider categorical data analysis, it will take minimum 1 hour. It may be more than 1 hour with software also. But Dr. Manapati Burman will show how to analyze in software regarding categorical data. In case of categorical data analysis, male and female, this side rural and urban. Rural, urban, male and female, 2 by 2 table. Then we will get the frequencies there. Only frequencies there. Sometimes we are interested to study, in case of categorical data, whether you have a particular disease or not. You means not a single person. It should be a sample. Particular disease, having disease or not disease, we may take some other variables, that is bit of smoking, height, weight, so many variables you can take. And we are going to use regression model. In that type of situation, then we use logic model. But logic is not model for categorical data analysis. Model started with linear probability. Then we can move to the logic model, probit model, and Tobit model, that is censored model, Tobit model. So many models are there. In this case, just I want to mention, my agote question is the misuse to statistics. আমি জনা বা নজনাকে আমি কি কৰো লজিক মডেলটো ফিট হৈ যায় 0 1 আছে ডিপেন্ডেন্ট আছে বা নাই এমাটো আছে বা নাই এসব মডেল ভাল হৈছে নাই এপ্লিকেবল হয় না নহয় না চাও আমি কি কৰো লজিক মডেলটো ফিট হৈ যায় ডাটা দিলেতো সফটওয়্যার ফিট হবই সফটওয়্যার হেতু কিন্তু বৰ ডাঙৰ ডিসএডভান্টেজ দুটা সেট অফ ডাটা ভৰাই দিলে তাত কি ফিট হবই কিবা এটা দেখুৱাবই কিন্তু হি একচুয়ালি থিওৰিটিক্যালি ৰিলেভেন্ট হয় না বা মডেলটো ভাল ফিটিং হৈছে না ৰেসিডুয়াল এনালাইসিস আমি কৰিছো না নাই নেছৱাকে আমি কি কৰো লজিক মডেল উই আৰ গোইং টু ultimately we will get some false result. And that may be accepted. Amar mota false kintu medical science apply korile he mote amake injection dile amar gate answer significant hodai with due respect to them sub analysis beya etu moi koa nai gotike ei je amar je collaboration to nai statistician medical person nai jene tene eton manu tar naitile hoy ba amak significant koi dibole ahe kichuna এটু নহয় আসলে কথা এক সিগনিফিকেন্ট কৰিবলৈ আহে মানে এটু সিগনিফিকেন্ট ওলাবই লাগিব এবোৰ জায়গাত ওলাইছে বিভিন্ন জায়গাত ওলাইছে যে এক্সট্ৰা সল্ট টেকিং ইজ ওয়ান অফ দা কজ অফ হাইপাৰটেনশন ডিব্ৰুগড়ত কেলে নোলাব গড়গাঁৱত কিয় নোলাব গড়গাঁৱত ওলাব লাগিব গতিকে যদি কিবা কাৰণত অন্য কাৰণত নোলাইছিলেও এক্সট্ৰা সল্ট টেকিং ইজ ওয়ান অফ দা কজ অফ হাইপাৰটেনশন ইউ মেক আমাক এই ডিমান্ড কৰে যে আপুনি এটু সিগনিফিকেন্ট কৰি দিয়ক সিগনিফিকেন্ট কৰা মানে হেতু এটা কজ বুলি ওলাই যাব या আগৰ স্টাডিটো কদি মিলাই লিখি দিব পেপাৰ পাবি গতিকে এইবিলাক আমিও দুখী তেখেতসকলো দুখী গতিকে আমাৰ বুজাবুজি নাই বন্ধুত্ব নাই data may be again discrete or continuous discrete or continuous discrete when it is discrete if you can count on number of defects you can count you cannot say number of defects 1.5 you can say number of defects 1 2 3 number of accidents to adha accident no hoy accident le eta accident de ba duta accident de adha accident etu no hoy accident hoy bole bhuri eta bhagile bole sai bhagore bhage hoise accident etu no hoy no accident or bhuri eta bhagi etu gotike hetu hol number of accidents and so many examples are here. Height and weight. Height can take any values between two limits. Weight can take any values between two limits. Here, over 5.6 inch, 5.7 inch. Over. So these are continuous. Based on continuous and discrete. Again, another classification is, I have already told that it is not a mutually exclusive classification. A time series data may be primary or secondary. A time series data may be discrete or continuous. Similarly, a cross-sectional data may be discrete or continuous. Pool data may be, actually it is a pool data. So, based on arrangement, we can classify three types of data. One is time series, cross-sectional, another one is pool data. This is the example of time series data. This is an arrangement of data in chronological order that is in accordance with time. 1961, 71, 81. This is a chronological order, population in 1000. These are real figure. Then list of latest population of 4 states of India. This is a cross-sectional. Here you see, we are not interested with the time. We are interested with the place. Assam, Kerala, Andhra Pradesh, and Karnataka. This is the point of time. In a particular year, we are not concerned about the year. In which state more, which state less, which state everything we can calculate if we take some other variables. So this is called cross-sectional data. Another type of data, you see, if you go to the first column, this is a year. If you go to the Assam figures, you forget about the Kerala, Andhra Pradesh, and Karnataka figure. If you see the Assam figure, this is a time series. Now you forget about the year. First step, Assam, Kerala, Andhra Pradesh, and Karnataka. What is this? This is the process. If you come through this one, then this is a time series. If you go this way, it is a cross-sectional. If you take one row only, then this is a cross-sectional. If you take a one column, this is a time series. As a whole, this is called pool data. There is statistical software to analyze pool data. Different techniques are there. At the same time, we have to take both data. Now, according to data, there are 4 scales of measurement, and I have prepared these things. Please don't mind those who are teachers are here and researchers. I am going to give more emphasis on students because more than 90% participants are students. I have got that. So 4 scale used with variable scales of measurement. With descriptive, there are 2 scales. One is ordinal, another is nominal. Continuous ratio scale and interval scale. আমি কিন্তু এখানে ধাৰ কৰিহে কৰি আছো আসলতে সাইকোমেট্ৰি মানে সাইকোলজিতে এখানে ডেভেলপ হৈছিল statistician ডেভেলপ কৰা নাই কিন্তু 4 scales of measurement, but we provided techniques to analyze of data. This type of according to statistician duty that has nominal scale. The nominal scale produces classification of persons or things based on a qualitative assessment of the characteristic being considered. There is no concept of greater than or less than. Yeah, blood group. Our blood group like AB or O. কোনোবাই ক'ব নেকি যে বিটকে এবিটো অলপ ভাল বেছি ডাঙৰ বি এটাও আছে লেটাৰ এ এটাও আছে ক'বতো নোৱাৰে গ্ৰেটাৰ দেন লেছ দেন কোনো কনসেপ্ট নাই জাস্ট দিস ইজ এ আমি এটা হাউস নাম্বাৰ এটা আছিলে কি 2 এটা ঘৰ মানুহটো ঘৰ বেলেগ হৈ গৈ কি হ'ল আৰু এ ঘৰ পুতেকে ঘৰ এটা বনা এই ঘৰটো সাজাৰ কাৰণে কি হ'ল আগতে গৈ হাউস নাম্বাৰ পাইছিলে কি 550 এও আসলে নাম্বার 1 ঘর 1 or 556 ঘর আমরা 556 to 5 1 ত ডাঙৰ ঘৰ নেকি এনেকুৱাটো কনসেপ্ট নাই বা কিবা কাৰণত ডাঙৰ নেকি হেতু কথা নাই ঘৰটো বাৰু ডাঙৰ হ'ব পাৰে পুতেকতে বনোৱা আৰসি বিল্ডিং বনাইছে হেতে ডাঙৰ হ'ব পাৰে কিন্তু বেলেগ কিছু সেইটো লাইনত মই যোৱা নাই কিন্তু কোনো ডাঙৰ সৰু কনসেপ্ট নাই ঘৰ ঘৰেই গতিকে হাউস নাম্বাৰ 813 272 or 372 religion, Hindu, Muslim, or others. You can use some codes. For A, B, or O blood group, you can use 0, 1, 2, 3, some code for statistical analysis or categorical analysis. This is categorical. Then ordinal scale. From the word, it is clear. Ordinal scale. That is, there is order. There is order. Here, the classification produced by this scale incorporate the importance of attributes greater than and less than. Kintu kiman dangor mane minus kori yate kori kiman dangor kiman horu yate. For example, performance of an employee okay boli kolu ejono good boli kolu ejono kam excellent boli excellent jonor good jonot koi kiman beshi kobo parim niki kiman beshi ba kobo parim thik tenore ami bikhor khetrot amar and get cancer treatment of stage 1, stage 2, stage 3, stage 4, stage 5 for us. At stage 1 or stage 2, big to iman basic, pain to iman basic. Isuman factor about victory. Into that, no concept I say, it say, stage 1 to deteriorate, stage 2 do. You go high. But again, like Angor Huru got had on my head. Isuman factor about victory or a bad head. Stage 1, stage 2, stage 3, stage 4. গতিকে কাৰোবাৰ কেতিয়াবা মিস ক্লাসিফিকেশনও হয় কোনোবাই যে অকমান বিখেলে পৰছি অভাৱ হৈ যায় ডাক্তৰ ক্লাসিফিকেশনটো কই কেনেকৈ হৈ থাকে কই স্টেজ 2 পৰে আসলে স্টেজ 1 আছে তেনেকুৱাও হয় then interval scale in interval scale one unit on the scale represents a small magnitude of the characteristic being measured across the whole range of the scale. For example, if anxiety were measured on an interval scale, then a difference between a score of 10 and 11, difference is what? 1. Here, difference is meaningful. Difference between 50 and 51, what? 1. But 51 by 50, Suppose 51, 50, 50 and 51 no. 50 and 50 and 100. 100 by 50 is what? 2. That means 2 times. 2 times. That is not meaningful. Here, for example, temperature. You see temperature. Today is hot. Next day, hot. But you are next day ইমান গুণ বেছি বুলি ক'ব নোৱাৰো ইমান টাইমছ বুলি আমি ক'ব নোৱাৰো মাল্টিপ্লিকেটিভ ফেক্টৰটো আমি ইউজ কৰিব নোৱাৰো আমি ইউজ কৰিব পাৰো যে এটো বেছি বুলি ক'ব টেম্পাৰেচাৰটো কালি 29 আজি 30 কিন্তু 29 কালি হয়তো বেছি লাগিছিলে খুব বৰষুণৰ পিছত এই বানপানীৰ পিছত হৈছে 29 টো ভাল আছিল আপনি 29 টো খুব বেছি লাগিছিলে 30 টো কিন্তু কম যেন লাগিছে পাঁচ দিলে কম যেন লাগিছে অলৰেডি 29 ৰ ৰাখিনা চলে আছে সেইটো কাৰণে কিন্তু 29 কে 30 বেছি হয় কিন্তু সেইটো অনুভৱত নহয় ইমান গুণ বেছি বুলি আমি ক'ব নোৱাৰো সেইটো পাৰ্টিকুলাৰলি টেম্পাৰেচাৰৰ ক্ষেত্ৰত আহিছে এনজাইটিৰ ক্ষেত্ৰত আহে গুণটো ক'ব নোৱাৰি যে ইয়াতে এনজাইটিটো বেছি কিন্তু কিমান গুণ বেছি সেইটো ক'ব নোৱাৰি this is the one scale that is called interval scale but generally we do not use interval scale these type of situations we use and day to day life we are generally use ordinal, nominal, and ratio scale. That difference is also meaningful. Plus, ratio is also meaningful. Today is suppose one person height, small person child height is 3 feet. Father's height is 6 feet. And father's height is twice of the son height. Or that is meaningful. That means 6 by 3 equal to 2. That one is meaningful. In earlier case, not meaningful. This is the difference between ratio and interval. In case of interval, you see there is no true 0 point. In case of temperature, 0 degree means no temperature, not meaningful. But height 0 means no height. Weight 0 means no weight. Nothing is there. No weight. 0. That is in case of ratio scale. But here 0 degree centigrade temperature means what? He has temperature. There is temperature. Minus is also temperature. So it may be very cold, but temperature is there. So conceptualization of I have written in the last conceptualization of 4 scales of scales presented above were first formulated in the context of psychometric rather than statistical. So we are going to use this thing. So this is one example. Earlier, Dr. BARMAN will show details about these things. And earlier, we take a questionnaire. Now we take a code book. This is called code book. Because then to enter the data in the computer, it is earlier we write rural or urban. Now we write 0 or 1. At the same time, you can enter the data in the laptop. If in the field you have the laptop. Rural, urban. Rural is 0, urban is 1. In which scale? It is in the nominal scale. Because rural can be 1, urban can be 0, or rural may be 1 lakh, urban may be 2 lakhs. You can give any code, but you don't forget that code up to the analysis. So why we generally use 0, 1. No hard and fast rule that you should keep 0, you should keep 1. You can give any code. You can use any numerical figure. 1 lakh, 2 lakh, you can use. But you don't forget in the analysis part that these are 1 lakh and 2 lakh. The interpretation is also complex. Interpretation will be complex. So why we generally use 0 and 1. Similarly, age of employee. Age of employee in years. It may be between 2 limits, any years. It may be points. Also, it is a continuous. Sex of employee, 0, 1. It is again nominal scale. Education. And age is also in the ratio scale. Education, it is in the ordinal scale. It is in the ordinal scale. because there is order we have to maintain. There is an order. Illiterate and primary education of the like that pain, ordinal case. Type of war, this is also ordinal. Chronic disease, this is nominal. Yes means 1, 0 means no. Working experience in years, it may be point also, so continuous. Number of awards received, it is a discrete variable. This is a discrete variable. So, in case of discrete, just you see which one? Ordinal scale and nominal scale. So, which scale here? So, this is the scale. So, number of awards received. It is in the ordinal because if you may have 1 award, other person may have 2 awards, etc. So, based on this, we divide data as statistics. That is, statistics is the science of decision making under uncertainty. Somebody may ask that what is this? We have read out that statistics is the science of collection, interpretation, tabulation, and analysis of quantitative data. So that definition is wrong. No, that is a part of the definition. Because to take decision under uncertainty, we have to collect information. We have to tabulate. We have to analyze. Everything will come under this. So this is the latest definition. Statistics is the science of decision making under uncertainty. In broad sense, statistics can be divided into 2 parts. One is descriptive statistics and another is inferential statistics. In inferential statistics, again 2 parts, estimation and testing of hypothesis. Now, statistics, descriptives and inferential statistics, I do not move in details of this. And these 2 are again not mutually exclusive. Descriptive statistical tools are used to describe the data in a concise form. If thousands of data are there, using mean, median, mode, we can give some picture of the data. That is descriptive. That description can be used in the sample also. In inferential statistics, sample is the best. Sample should be again scientific. Sample should be scientific means random. If it is not random, we should not use test of significance statistics. If sample is random, randomly taken, যেটো আমি অসমীয়াত কওঁ যাদৃচ্ছিকভাৱে যদি স্যাম্পলটো লোৱা হয় তেতিয়াহে আমি টেষ্ট অফ সিগনিফিকেন্স ইউজ কৰিব নহলে নহয় বেসিক requirement is sample should be random. এবেলে আমি গলু ডাটা কালেক্ট কৰিলো যত ভালকে চাহ খাবলৈ পাই তাৰ পৰা ডাটা কিটা কালেক্ট কৰি আনিলো নিলে বলে আমি এনালাইসিস কৰিলো কৰি পেলাই এটা ৰিজাল্ট দি দিলো সেইটো আমাৰ হয় নাথিব জাক পৰা কালেক্ট কৰিব লাগিব সেইটো সাইন্টিফিক্যালি আমি ঠিক কৰিম যেটো মই চাউল বেগৰ ক্ষেত্ৰত কলুই আৰম্ভণি পাই চাউল আনিলে বিপদ আছে so the classification is not mutually exclusive. Different tools have been developing under this classification according to demand of the society from time to time. As a result, the discipline of statistics has given part of some new disciplines I have already told, that is econometrics, bioinformatics, also statistical tools are using, and many different branches are there, biostatistics and epidemiology also now we are using statistics. So different branches are developed based on the demand of their demand. We are developing some tools, and accordingly these are different. That may be a descriptive statistics, that may be inferential statistics, but in case of other discipline, inferential statistics is the base because without drawing inference, you cannot give control. And how to give inference, that will take another one lecture. Today not possible. So now, as I have mentioned, just I will take 5 minutes and misuse and wrong use of statistics. খুব সহজ এটা মই কথা কওঁ আমি এটা সার্ভে কৰি আসলে সার্ভেটো উদ্দেশ্য অন্য আছিল লগতে এটো ওলাল যে এক্সিডেন্ট বিলাক সাধাৰণতে কি হয় near the footpath in the left side from this side car is going on In the left side, accident is more. আমি data collect কৰি সেইটো কম। Our conclusion is walking on the middle of the road is safety. কেতিয়াও নিদিব আগতে এইটো conclusion বনাও। Walking on the middle of the road is safety. I have given explanation. তাৰ মানে ৰাস্তা কাষতে এক্সিডেন্টবোৰ হয়, গতিকে আমি মাজেদি খোজকাঢ়ি যোৱাটো নিৰাপদ। Is it correct? Have you allowed persons to walk in the middle of the road? We have not allowed. Allow কৰি আমি সেইটো সার্ভে কৰিবলৈ হলে আমি আগতে যেনি যাব পাৰে বুলি ক'ব লাগিব। তাৰপাছতে খুব বেছি হয়তো গম পাম ৰাস্তাৰ মাজেদিও যাব পাৰে, আপুনি কাষেদিও যাব পাৰে, যেনি মন যায় তেনি যাব পাৰে, তেতিয়াহে সার্ভেটো হ'ব। ৰাস্তাৰ কাষত বেছি হৈছে হয়, সেই বুলি আমি ক'ব নোৱাৰো যে walking on the middle of the road is safety. You cannot say like that. Similarly, misuse of descriptive statistics. মই অলপ আগতে কৈছোই the sample random হ'ব লাগিব। তাৰ উপৰিও misuse, এটা correct result, average number of patients die in the operation. One day there was a patient, they are waiting to the for operation. Now for that particular day he had asked through a journal. Journal means magazine. In magazine it is written that in that particular operation 20% died in the operation theater. 20% died in the operation theater. তাৰমানে 5 জন মানুহ হলে 4 জন মৰিব এজন। Okay, 4 জন জীয়াই থাকিব এজন। On average 20% died in the operation theater. On average 20% died in the operation theater. He was not a man of statistics. Magazine খনত পালে যে 20% মানুহ operation theater. On that day he is the number 5. All fours are alive. এইজন মানুহ ধুনীয়াকৈ অপাৰেশ্যন কৰিব আহিলে, এইটো চালাই নাই হাতত লৈ পলাল। কিয় পলাল? কাৰণ 20% out of 5 1 এজনটো জীয়াই নাথাকে, হেন তো মৰিবই, ধৰিয়ে ললে। This is again a misuse of descriptive. কথাটো হল তাত কোৱা হৈছিল এভাৰেজ, কেউটো এভাৰেজ কি বস্তু নাজানে, ষ্টেটিষ্টিক্স নাজানে, গতিকে মেগাজিনত সেই কথাবিলাক পপুলাৰ আৰ্টিকল লিখোতে খুব সেইটো এটা ভুল। আৰু লগতে তেওঁ সেই সময় মেগাজিনখন খুলি দিয়া এটেন্ডেন্টৰো ভুল আছে, সেই এটা এভাৰেজ চকুত নপৰিবও পাৰে, কাৰণ হি ইজ গোইং টু টেক অপাৰেটৰ্ছ। সো এইটো এটা মিছ ইউজ যে আজি ষ্টেটিষ্টিক্স এই মানুহটো একদম বৰবাদ কৰি পেলালে। Use of test of significance, I have already told, in non-random sample. Is not random. We are going to use t-test, chi-square test. Many persons are coming, have been coming to us, to meet us. Sir, how to calculate t-test, what is acting, and also variance, this type of things here. These are data. Yes, we can use, but sampling is not random. Then how you can give the inference? That may be true for that particular group of data. Particular group of data that may be the observation. Just you show the descriptive statistics. You don't go for statistical inference. You use t-test, f-test, chi-square test. কোনোবাই ক'ব যে তেখেতেও নজনাকে ক'ব যে কেলে তুমি t-test কৰিব পাৰিলা নহয়, এইটো দুটা সেট ডাটা আছে, দুটা সেট ডাটা থাকিলে t-test, chi-square test, f-test কৰিব নোৱাৰি। That samples should be random. This is the prerequisite condition, because all distributions are derived based on random sampling. You know sampling distribution, sampling factor, those who are familiar more on statistics, we know. So it is not possible. So finally, I want to show one example of correlation and regression. One is use, another is both are misinterpretation or misuse type of things. Regression analysis, generally we have two variables. Sometimes we use one as a response variable or cause as less response. X is to control the Y. Sometimes it is correct. In a particular example, daily electricity consumption and average daily temperature during July, August in Guwahati. So there is a positive high degree of positive correlation. It is obvious when temperature increases, then electricity consumption also increases. It is obvious. So there is a positive correlation. Now you have used regression model. Y equal to A plus BX plus this. Explained variable is average daily temperature. Explained variable is daily electricity consumption. Results, regression model is fitted well. Both the coefficients are also seen. Now what is this? X is control, Y is the response. I have given 2 question marks. It is not correct decision. X is the control, Y is the response. X or Y control. What is X now? What is X? X is explained variable daily electricity consumption. Y is what? Average daily temperature. If you cut the consumption, can you control the average temperature? Into bohutot dekha jay je X of control hisabe Y karone ব্যবহার করি। Itu correlation to olaboi eta bahile andu bahiboi. Positive degree correlation olaba, high degree of positive correlation olaboi. Sei karone ami X of control kori Y control kori jodi jao suggestion diu tene hole to is a very wrong decision. You cannot control Y with the help of X. Not, there is no cause and effect relationship. So regression analysis, regression always does not imply cause effect analysis. You don't forget. This is a common mistake generally done in other subjects or including statistics also. Without theoretical elements, we are going to use the statistics. So practical knowledge is very much essential, more than the essential than our tools. Knowing or unknowing using tools are not a good decision. Now, if you come to this data, I don't know whether it is visible or not. First, X is 18, Y is 124, 324. X is 4, Y is 16. 9, 81. So 11, 121. Now, we have fitted the regression. This is different from other earlier. Y equal to A plus BX, we have got Y cap equal to minus 165.33 plus 31x. Regression statistics, R equal to 0.97, correlation division. R square 0.94, adjusted R square 0.90. Using F table, we have got F is a very significant one. That means model is a good fitting. Using R square, we have got the model is very good. But what is the data in real? You see. 116, 981, 4, 2, not, it should be 24. I have put it wrongly. 30, 900, 6, 36, 7, 49, exactly, 8, 64, 3, 9. Reverse order. Some mistakes were there in putting data, but all are like Y equal to X. It is Y equal to X. So linear model is not a correct one. So with the help of R square only, we should not keep that. There is another technique that is residual analysis. In residual analysis, this graph should show one positive graph or negative graph, one trend that should show. But what is the residual analysis you see? This is the graph. This is the U-shaped graph. That means model is. Without showing this, without testing this, we have concluded that our model is good fit. This is not a correct decision. Y equal to X squared, that is a quadratic relation. We are going to place it using what? Linear relation. Y equal to A plus BX. It's a wrong decision. Due to what? Less use of statistics, not misuse, less use. Just we have used the R square. So conclusion is, R-square alone, you cannot give a conclusion about the model fitting, regression model fitting, whether your regression model is good fitted or not good fitted. You cannot conclude about that. So these are some scatter diagram about the residual analysis. So what is this? So I can summarize. Making decisions in statistics is a challenge. It is a challenge. Decision is challenge. I have already given one example. Decision is yours. Yours means organization. Yours means statisticians. It may be a group of statisticians or one expert, maybe, but decision is yours. It is a challenge. Statistics is the science of decision making under uncertainty. There is communication gap between statisticians and statistical data may be numerical, or you have to put it numerically before going to analysis the data. That may be classified on the basis of source of collection, primary and secondary, variable associated, discrete continuous, arrangement, time series, cross-sectional full data, and so on and so forth. The knowledge of four scales of measurement, that is nominal, ordinal, ratio, and interval, is essential of data handling either in statistical software or manual. These are essential. In most of the cases I have seen in ordinal data, in questionnaire 0, 1, 2 up to 5, disagree to, started from disagree, suppose 0, then moderately or some timings are words up to 5. Then they are going to use this is ordinal data. Ordinal data. How do you use test of significance? So different tools are there according to data, according to scales of measurement. It depends on your scales. Likert scale, for example, Likert scale in psychology. You cannot use directly t-test or chi-square test. Chi-square test you may use, t-test you cannot use. Because this is ordinal data. You will get the frequency. How many frequencies against 0, how many frequencies against 1, how many frequencies against 2, and so on, so forth. But you cannot use directly that t-test 0, 1, 2, 3, 4, 5. The range is only 0, 1, 2, 3, 4, 5. Another says it is again 0, 1, 2, 3.5. You are going to use t-test. That is not permissible. Your judgment based on observation is more important. I have repeatedly told you. সেইকাৰণে আমাক কয় যে আমাৰ পৰিসাংখ্যিক বস্তু সেইবিলাক ভুল ষ্টেটিষ্টিক্স দিয়াহে কেনে কয় মই এদিন ৰেডিঅ' শুনি গৈছিলো ইলেকশ্যন অপিনিয়ন পোলৰ সময় এইটো ইলেকশ্যনৰ নহয় ইয়াৰ আগৰ ইলেকশ্যনৰ অপিনিয়ন পোলত খুব ভুল হৈছিল আগৰটো নেকি তেতিয়া ৰেডিঅ'টো মই গাড়ীত শুনি গৈছিলো শুনি যাওঁতে তেতিয়া এজনে কৈছে মোৰ একদম গাত লাগি গৈছে এইবোৰ আচলতে ষ্টেটিষ্টিকেলহে আছিলে গতিকে ভুল হ'বই পাৰে ষ্টেটিষ্টিকেলটো ভুল নহয় ভালকে চেম্পলে লোৱা নাই আজিকালি অলপ চেম্পলটো ভালকে লৈছে আগতে এতিয়াও নাই proper multi-stage, multi-phase, stratification, everything has to be made before going to collect sampling. And it will cost around election costs. So just giving that type of opinion, I neglect it actually. Statistical, the knowledge of four scale is necessary. Your judgment based on observation is more important than the finding based on statistics. Sometimes statistical significance does not imply theoretical relevance. I have shown one example that y equal to x square is the correct model, but our statistical significance shows that y equal to a plus due to non-observation and due to less use of statistics. You have to show why. Sometimes somebody asks, this says that this is significant. Why you are going to use this type of all the tools? Because if one tool rejects, I can. If so many options are there, you should use all the options up to the permissible. If possible, you use all the options. If one option says no, some option says yes, then you have to look into the data or theoretical relevance. What happened? If you see in biological science, particularly in medical science, if a wrong decision will provide by the statistical significance, then we are the human being. It may be for the medicines. We are very careful. We should be very careful. If theoretical relevance coincide with statistical significance, it will be a best decision. Jodi theoretical relevance to aru statistical significance to coincide kore, then a very good decision, best decision. Decision statistics. So you move to the first slide. In the first slide, I have told eta maths jodi hatot dia hoy apuni he maths tore ki koibo pare edokhor andhar jega pohoro goi dibo pare naiba koibo pare eta building cholai dibo ekta message. It is up to you whether you give the bright to the dark place or whether you destroy the building. So we should be very careful because today is the day of birthday of PC Mahalnavis. PC Mahalnavis, he was very careful in using data. Somebody says that data tells everything. No. Proper interpretation of data tells everything. Without proper interpretation, you cannot say data tells everything. So this is about the presentations and why PC Mahalnavis is famous for this. Everything is included here. You see, without PC Mahalnavis, you cannot go to this whatever I have presented. And PC Mahalnavis is the so far first person from the science of statistics who awarded Padma Vibhushan. Only he is the person so far. So I expect from all of these statisticians, again, we will get some good persons for the future. In this opportunity, I should name one of our some famous statistician. Perhaps all of you know Professor J. Medi. He was a known figure. Now also he is a known figure in all over the world. Okay, with these words, with this presentation, again, thanks to the Department of Statistics, Gargaon College, particularly Ranjana Baidu. I say as Ranjana Baidu. Dr. Mrs. Ranjana Gogoi, head of the department, Bornali, and participants for patient hearing. Whether you have been benefited from my lecture or not, I don't know. I will get the feedback, I think, later on about this. It is a very basic lecture, basic about the preliminaries of statistics. Thank you, and thanks to the college authority, Principal Dr. Abhasi Mohanto, and other faculties associated with this, including Purohit Chaitya and other persons. All I offer my thanks for giving me opportunity in this during this COVID pandemic. Thank you.
Thank you, sir. Thank you, Professor Hazarika, for your beautiful deliberation and excellent explanation on the basic do's and don'ts in data-driven research. Tare bor sundor ke kotha khini kole oti koru koru udahoron di.
Any queries?
Am I audible to sir?
I may not be able to answer. I may not be able to answer. I am not an expert. But if any queries, I want to know.
Sir, we have decided to the session for question answer after the Dr. Barman's presentation.
Very good, very good, very good.
Okay.
That means you must say it up to Dr. Manapati. Okay, thank you.
Thank you, sir.
Okay.
You have explained very beautifully the basic do's and don'ts in data-driven research. I hope all the participants are benefited from your deliberation. And after completing our second lecture that will be delivered by Dr. Manaspratim Barman, the question answer session will be start. And from one participant, only one question will be put to the resource person. Thank you, sir. And I invite Dr. Manaspratim Barman, Associate Professor of Statistics, DIBRUGARH University, to deliver his presentation. Thank you.
Good session, Bernard. Surajit 90.
Yes,
Yes, sir.
Okay.
Manas, sir, I am doing. Yes, you can, sir. The setting has done. You can share your screen, sir.
Myself.
Yes, yes,
Good.
sir. Yes, sir. So you can share, sir.
Right.
Screen share কৰিব পাৰিব?
নাই মই পোৱাই নাই অপশনটো অহা নাই
কিয় অহা নাই? তলত আছে নাই নেকি screen share?
মই সেটিংটো কিন্তু ঠিক কৰি দিলো।
ৰ এক মিনিট হৈ গ'ল yes yes
Yes, okay.
Okay.
Wait to start video to captain.
প্ৰেজেন্টেশনটো কি হ'ল Hello everybody, I am Dr. Manaspratim Barman. Today, first of all, I want to thank the organizers for giving me the opportunity to speak in front of you. Today, I will talk on statistical analysis using computer software, SPSS. I will try to finish it by 12. I have very little time left. Okay, and now, why statistical analysis is important? That is more important, and I know that this group is very heterogeneous. A lot of students are also are participants, so I will try to keep it very simple. And I'll just before starting SPSS, I will talk on some basic things. So why statistical analysis is important? So I have given some definition of statistics. I have given definition of statistics given by famous statisticians. Statistics may be defined as the collection of presentation, analysis, and interpretation of numerical data. This first definition says that in statistics, what we do, we collect the data scientifically, presented it properly, and analyze the data. And from the analysis, we have to give interpretation. We have to make decisions. Okay. So analysis is the part and parcel of statistical process. Okay. So statistics is very much important. Now, there are a number of statistical packages available for analyzing data. First, I have to tell the name of MS Excel. MS Excel is a very powerful statistical tool for analyzing statistical data. It has a lot of options for doing statistical analysis. Descriptive statistics, inferential statistics, graphs can be done in MS Excel. And the most important thing is that it is freely available. So we can use Excel also for doing statistical analysis. And now that the latest version of Excel are very powerful, they have included very advanced statistical method also. We can do multivariate analysis in statistics also. Okay. Next, I have to tell the name of SPSS. Initially, SPSS is developed for analyzing social sciences data. It was called as SPSS means statistical packages for social sciences. But nowadays, people from all the different branches of science humanities are also using SPSS. That's why now it is no longer statistical packages for social sciences. It is only called SPSS, right? Then we have EPInfo. EPInfo is also a very popular software. It is actually developed by World Health Organization to analyze epidemiological data. In epidemiological data, most type of data are categorical. Okay, if you do some epidemiological study, you can find that most of the data are categorical. It is not continuous, actually discrete data. Epidemiological data are particular discrete data. Okay, so this EPInfo is designed for analyzing categorical data, discrete data. It's a very good software and free. You can download it from internet and you can do analysis by using EPInfo. Then Strata and Minitab are equivalent to SPSS. They are also very costly like SPSS. But this has lot of functions are there. Then R is fully free software. You can download it very easily from internet. And SPSS and R are newly included in the undergraduate syllabus. Then MATLAB. MATLAB is also very powerful. And Python. Python is nowadays Python is very popular in doing statistical analysis. Python can be used to do graph design. A lot of things can be done with the help of with the help of Python instead of statistical analysis. It can be used to it can be used to web design also. In web designing also it can be used. Now suppose before doing statistical analysis, what we will need? We need some data, right? We need some data. Now we can collect the data by primary source or by secondary source. By primary source, to do primary source, collect primary data, we have to go to the field or collect the data from individuals or from suppose some shops like this. And if I use secondary data, then I have to go to I have to collect it from the magazine website like this. Suppose before doing the statistical analysis, we are planning a survey. Suppose, okay, we plan a survey and we will do data collection, collect primary data, and we will do the analysis using that primary data, right? Now, suppose for collecting primary data, what we have to do first? We have to make a questionnaire. Okay, we have to make a questionnaire. So let us make a questionnaire. Suppose this is a questionnaire I have made. Suppose questionnaire on studying hypertension, right? That means I want to study the blood pressure level of a community. How many people are infected from blood pressure? Okay, so this is a medical related, health related survey. So I make this questionnaire. So this is the questionnaire. So first question is that name of the respondent. I have to collect the name of the respondent. Then his residential status. He is coming from rural or urban area. Age of the respondent. Then sex of the respondent. Education of the respondent. Type of work. Our main objective is main variables are these two. Systolic blood pressure and diastolic blood pressure. Blood pressures, everybody I think know how to make blood pressure by using sphygmomanometer. So when we read blood pressure, we will get two readings. One is systolic blood pressure, one is diastolic blood pressure, right? So these are the two main variables, right? And we have collect information on some other variables, auxiliary variables also. Okay, this auxiliary information is also very useful actually. Suppose I want to know what are the main causes of the blood pressure, then we have to collect information on the auxiliary variables also. Okay, right? Auxiliary variables also. So that's why we are going to collect information instead of we are going to collect information on blood pressure and also information on other auxiliary variables, right? So these are the variables we have taken. Right. So our first purpose is to you have to first read the questionnaire very well before doing the analysis or before collecting the data. You have to know your questionnaire properly. Okay, so you have to read it. Okay, you have to know every questions. Then this is the questionnaire. Okay. Now Suppose my sample size is 300. Okay, I am going to 300 individual. I have to go to 300 individuals and collect information on this question by using this questionnaire from all the individuals, right? So suppose this is a sample questionnaire. Okay, name of the, so I went to the field and collect this information from the respondents. So first name of the respondent is suppose AA. Suppose residential status is rural, that means that person belongs to a rural area. Then age of the respondent is 46 years. Then sex of the respondent is female. Education is suppose graduation. Then type of work is suppose active. Okay. Then family history of hypertension means whether his parents are also suffering from the disease or not. Okay, well, I want to see whether people with family history is more chances, there is more chance of hypertension among the people whose family history of hypertension, who have a family history of hypertension, right? I want to see that. That's why I'm taking this information, right? Okay, then height, weight. This height and weight are used. We have collected the information of height and weight to measure the obesity of a person, how fatness of the person. So fatness is also related to blood pressure. Everybody knows that. So to calculate the fatness, we need to take the data on height and weight also. So these are the data we have collected, right? I think everybody understand this one. So his family history, yes, that means his parents are also suffering from the disease. His height is 5.4 meters. It is not meter, it should be feet. And then weight is 76 kg. His systolic blood pressure is 137. His diastolic blood pressure is 84. So I collected this information from the field. Okay, and likewise, I have to go to that 300 individual and fill up this same questionnaire from the 300 individuals, right? Now let us suppose I arrange the collected data. Okay, so in the columns I have the name of the respondent. In the columns, head of the columns, I have the name of the variables. So name of the respondent, residential status, then age, then sex, then education. Okay. Then in this particular row, I have to put all the characteristics of the first individual. First individual name is this one. Then he's from rural area. Then his age is 60 years. She's a female. Her education is primary education. Okay. So names are something, you know, this data actually collected in Mizoram. That's why names are not familiar. Okay. So these are real data I have taken. These data are collected in Mizoram. That's why it is names are not familiar to you. Oh, this is the name of the second person. His residential status is rural. His age is 25 years. His sex is female. And his education is graduation and above. Like this, I have to arrange all the data. Now, the main problem is that you see only age is the numerical data. Residential is not numerical. Sex is not numerical. Education is also not numerical, right? So statistical methods are developed to analyze only numerical data. So we cannot analyze the residential status, we cannot analyze sex, we cannot analyze education. But if I ignore these variables, then I will lose a lot of information. Okay, so the main thing is what? So these are called, and also these are also called, I forgot to tell one thing, these variables are also called categorical variable because it has only two categories. Suppose two categories. Now, if I ask a person, what is your residential status? He will tell either my status is rural or urban. Not instead, these are only the two outcomes. Okay. So this is a categorical variable. It has only two categories. The outcomes are only two categories, rural or urban, right? Then same way, sex is also sex is also a categorical variables. It has two categories, which has female or male. Instead of this, no values it will take, right? Then education is also a categorical variable. It has only 5 categories: illiterate, primary, middle, up to SSLC, ASS, and up to SS and graduation. So these are the categories. So only one variable is numerical. So what we have to do? We cannot ignore the variables, alphabetical variables also, because they will give us a lot of information. Nah? So what we do, we make them numeric by assigning numerical codes. We will assign numerical codes to them, and it will be, so we'll do what? We will give them some particular codes, numerical codes, so that it becomes numeric and we can do the analysis with the help of this data. So we make a code book. So making of a code book is very, very important. So this is a code book, right? Code book, you always make a code book. After making the questionnaire, you always make a code book. So my code will be like this: name of the respondent. Name of the respondent, we cannot code it. So residential status, suppose rural I give 0, urban I give 1. Age of the respondent, this is, the code is not necessary here. We will have figures for this. Then sex of the respondent, male is 0, female is 1. Then education, I coded illiterate 1, primary 2, up to SSLC 3, ACES 4, graduate and above 5. Then type of work, I give sedentary 1, active 2, heavy 3. Family history of hypertension, I give 1 equal to yes and no 0. So this is height. These are continuous variables. So I don't need to give codes. They are not categorical variables. Only we have to give codes to only categorical variables, right? Now, so I make a start of the variables. So variables are divided into two parts: discrete and continuous, right? So discrete, Sir already told you about the measures of scales of data. So we have 4 measures of scales: nominal, ordinal, ratio, and interval. So discrete is divided into nominal and ordinal scale. So residential status is a nominal scale, sex is nominal scale, family history of hypertension is nominal, then education is ordinal, type of work. Why residential status is ordinal, nominal? Because nominal means here we give the codes just to identify a particular category. We are not following any rules while giving the categories. Okay, suppose I am given rural as 0, urban is 1. This does not mean that I am giving more value to urban area. It does not mean that urban people are good. Okay, I am just giving these values to identify it. So it is called nominal. So sex is also, I have given male as 0, female as 1. It does not imply that females get one value, so it is they are better than male. It is not like that. We are giving these values to. Am I audible?
Yes, you are audible.
Hello.
Yes.
Welcome to AAB. Am I audible?
Yes, you are audible.
Okay.
Yes.
Okay. Hello. Okay. So we have this. So residential status. Okay. Residential status, sex, family history of hypertension are nominal variables, right? So we have given, suppose in family history of hypertension, we have given yes is 1, no is 0. So this is just to identify. Okay, not this is not like that no people are less better than the yes people, because I have given more values to yes. So this is the way you can identify category or nominal variables and ordinal variables. Now you see here the education and type of work. Education, in this category you see illiterate I have given 1, primary I have given 2, SSLC I have given 3, ACES 4. These are in a particular order now. So this is not like that if I put illiterate is 3 up to SSLC 1, it will not work. Okay, it is in a particular order. So it is called ordinal variables. Likewise, type of work is also an ordinal variable because it is in a particular work order. Okay, so those categorical variables which have particular orders, then we call it ordinal variables, and those variables which don't have any order, so it's called nominal variables, right? I think you are understand now. Now, ratio scale. So these are the continuous variables. Why these are continuous variables? Because these variables can take decimal places. Okay, say my age maybe suppose 40 years 6 months, so 40.6 like this. So height, weight, like these also are ordinal variable, no, continuous variables. So these are all ratio scale because 0 is meaningful here. Okay, sir already told you this thing. I don't want to talk about this much. So we have separated all the variables according to nominal, ordinal, ratio, and interval. The knowledge of this thing is very important while analyzing your data. Okay, so you cannot apply all the statistical method in all types of data. For nominal variables, you have to apply a different type of statistical method. For continuous variable, you have to apply different statistical method. You cannot apply mean for or nominal data. I can give you an explanation example. Suppose I collected information on 5 individuals. Suppose these are suppose sex. Okay, so I collect information on 5 individuals. First one is male, second one is male, third one is female, fourth one is male, fifth one is male. Suppose I want to find the mean. Mean means sum of all these values divided by number of observations. So it will be what? 1 divided by 5. That means what? It will be what? Point something, 0.2 something. Okay, that's mean it. Does it mean anything? Mean sex is 0.2 something. Does it mean anything? No. So for nominal variables, we cannot apply this mean or standard deviation like this type of measures. So knowledge of the type of variable is very, very important. Okay. Okay. Now these are the different steps of data analysis. Now after collecting the data and after making the code book, what we have to do, we have to create a database. If I want to use computer software, I have to create a database. Okay. For creating the database, I have to do data entry and I have to list the name of the variables. So this is the most important part of doing a statistical analysis. You cannot directly go to analyze the things. First of all, you have to enter the data. You have to create a database. Then the important thing is editing of your data. Editing is also very, very important while analyzing the data. If you edit the data properly, then it will analysis will be very easy for you. Okay. So what you get in the field is a raw data. Okay. It must need process. You have to process your data before doing the actual analysis of the data, right? So I will show you how to edit your data. I will show, because time is very short, I will show you some of the ways of editing the data, right? So one thing is very important here. I have highlighted statistical analysis should be done according to the objectives. So what data we have collected, we can do a lot of calculations, but we will stick to the objective. We have to stick to the objective of the study. Okay, it will be depend on the objective of the study, right? So type of analysis, descriptive statistics and inferential statistics. Now let us start about SPSS. So as I have already told, as earlier it was SPSS was called Statistical Packages for Social Sciences, but it is called only SPSS. Okay, so SPSS comes in modules. So SPSS is a package for programs for manipulating, analyzing, presenting data. This package is widely used in social and behavioral sciences. there are several forms of SPSS. The core program is called SPSS base. If you process SPSS, it will come in this module, SPSS base module. Then if you need some other module, suppose advanced model or regression model, you have to process it separately. And it will give lot of option to do regression analysis. If you process the SPSS regression model, then it will provide you lot of option for analyzing regression models. Now let us open SPSS. To open SPSS, you have to first install the SPSS. Okay, I have already installed it in my computer, so I have to go to this, then SPSS window. I'll show you SPSS 20 version. I think the latest version is 26 now, so I have 20 version. So I will show you. I think there is not much differences there. Both are more or less the same. So let us open SPSS. It is taking some time. Go to start SPSS. So it is opening. So this window comes at first. SPSS was actually after version 17, SPSS was purchased by IBM. It is now more called IBM. Okay, so this is the window. So this small window here, these things give you the list of files that I have already used. Okay, if I don't want to use, if I want to open the used file, then I have to click here and click OK. But I don't need this one right now, so I click it cancel. Okay, now you see this is, so this is what, this is SPSS, and these are the menus. In the top of the line we have the menus, right? So the first three menus are same as Excel: file, edit, and view menu. These are same as Excel. Now these two menus, data and transform, these menus are used to edit your data. These are very, very useful for while analyzing. These two options are used to edit the data, right? Then we have analysis menu. With the help of analyze menu, we can analyze. We have a lot of options here to analyze the data. Suppose descriptive statistics, compare means. Here we have different tests are available. General linear models, we have different models. Correlation we can do here. Regression we can do here. Neural networks, then classify. This is used to use cluster analysis. For doing cluster analysis, this classify is used. Dimension reduction is used for factor analysis and principal component analysis. Then we have different non-parametric trace, then survival analysis. So a lot of options are here for in SPSS to do and statistical analysis. Now this is the graphs. Here we can make different graphs also. It's very easy. First of all, you have to enter your data, then you have to edit the data, then you can do any analysis in SPSS, right? Okay, now you can see in the bottom, you see these two. Here, there are two tabs, right? These are two tabs. One is data view, one is variable view. Okay, so these two tabs are very, very important. If you use data view, then you can see the data that you have entered. And in variable view, you have to list all the variables you have, right? So before doing the analysis, I have to make a database, and with the help of, I will show you how to make a database here, right? First of all, this is very important, and then you can do the editing, and then you have to go for analysis of the data. So in data view, we see the data, and variable view, we have to see the variables. So we have how many variables in our data study? So these are the variables. Name of the respondent is a variable, residential status is a variable, age of the respondent is a variable, sex of the respondent is a variable, education is a variable. So we have to enter them one by one in SPSS. Okay, the name of the variables first we have to enter. Okay, so you see, so you have to list all the variables in variable view. Variable view, in the variable, you click variable view, then this window comes. Here we have to list all the variables one by one. In one row you have to list one variable, in second row you have to list the second variable, in the third row you have to list the third variable, in the fourth row you have to list the fourth variable. Like this you have to list it. Okay, so in this row, in the first row, I have to put all the characteristics of the first variable, the name of the variable, the type of the variable, the number of characters it will take, level, values, all the things are here. So we have to put all the variables here. So first of all, so this is the list of the variable. Name of the respondent is the first variable. So I have to first what? Here in this list row, I have to put the name of the variables. Okay, for name of the respondent. So first of all, I have to give a name of the variable. So first of all, I have to give a name of the variables. I cannot give any name. Okay, suppose name of the respondent. First variable name is name of the respondent. You see, let us write name of the respondent. Okay, so click it here. You see, variable name contains an illegal character. That means you cannot give any variable name. We have to follow certain rules to give the variable names. Okay, so I will show you what the rules you have to follow for giving the variable names. So these are the rules. Okay, these are the rules you have to follow while giving a name of the variable, right? So first rule is, in SPSS version 12 or later, a variable name can have maximum 64 characters made up of letters or numbers. Okay, in earlier version only 8 characters. So in the when you give the name of the variable, it must contain maximum of 64 characters, not more than that. Okay, your variable name must be within 1 to 64 characters. Okay, then characters made up of letters or numbers. So you can give numbers or letters also in your variable name. Okay, so this is the first rule. Okay, you can give any, suppose my first variable is like this. I put the variable is like this. So Q1, first question, this is my variable name. So it consists of letters and numbers. It will take, right? Then variable name must begin with a letter or this character. So second important thing is that variable name must begin with a letter. So it cannot begin with a number. Okay, you have to clearly remember that it must begin with a letter, not a number. So suppose I want to give the first variable name as 1. Suppose it is suppose 1. I want to give the variable name as 1 because this is the first question. So 1. You see, variable name contains an illegal first character. So you have to start with a letter, or not a number, right? This is the second rule. Then a variable name cannot contain blank spaces. Okay, so your variable name cannot contain, this is very important. Suppose I have already told you that first variable name is name of the respondent. Suppose I gave the variable name is name of the, I have given space here, respondent. Okay, so you see, variable name contains an illegal character. Why it is illegal? Because I am giving space. So in SPSS, we space, while giving the variable name, space is not allowed, right? Okay, so this is the important thing. A variable name contains blank cases, and these characters you cannot give. A variable name must be unique. No variable in the data have same variable name. So a variable name must be unique in SPSS. Suppose I am giving an example. Suppose I am collecting information of age of husband and wife both. Okay, So for the age of husband, I want to enter. So I give the variable name as suppose age, right? For this age variable is for husband, suppose, and for wife, I want to give same variable name age. So if I click here, you see what is this variable name duplicates an existing name. So a variable name you cannot give the same variable name in two variables. Okay. So for that, suppose I give like this, W means wife. Now it will take. Okay. So you cannot give same variable name to two variables. Okay. Now the period, underscore, and these characters can be used in variable name. So underscore, this character, and $sign and period sign, these can be used in creating a variables. Okay. Now let us make a variable. Okay. So what my first variable is name of the respondent. So I have to give a name of the variable. So suppose my name of the variable is name underscore, because underscore is considered by SPSS, not space. Name respondent, right? Okay. So name respondent. Now it takes. So you see name respondent is my first variable name. Okay. Now here we have to specify the type of the data you are going to enter in this variable, right? You have to specify the type of data you are going to enter in the variable. So what type of data we are going to enter? Here we have to enter alphabetical data. By default, it is numeric here. But now I have to enter alphabetical data here. So what we have to do, I have to click to change it. I have to click here, and this is the list of different type of variables, right? So I have to select string. String means alphabetical data, right? Click here, string. Now we can enter alphabetical data here. Now width is here by default, the width is 8. So now by default the width is 8. So what we have to do, it will take only 8 characters. Suppose in my name I have 16 characters, Manaspati Barman. So if I enter my name, so it will take only first 8 characters. So if I want to increase it, I have to click it here and increase it like this. Okay. So there is no question of decimal places here, because this is a alphabetical data. So no question of decimal places. Now level. Level is used to explain the variable. Okay. Level is used to explain the variable. Suppose instead of name of the respondent, I give variable name as Q1. Okay. Okay. Now Q1. Suppose after some time you forgot what is Q1. So you can explain that. You can explain this here by name of the respondent. Here there is no such rules. You can type anything here. So level is used to explain your variable. If you because your variable name should be always brief. Okay, your variable name should be brief, and by using the level you can explain the variable. Okay, so values is not required because it is a string variable, alphabetical variable, so values is not required here. So I have constructed the first variable. You see it will come here. If I click on data view, this is variable view. If I click on data view, so you see here it comes. Now you can type anything. This is the name of the first person. This is the name of the second person. This is the name of the third person. This is the name of the fourth person. This is the name of the fifth person, like this. Okay. So I have created the first variable. Now second variable is residential status. So suppose I have given the name as location. Okay. So it is a what type of variable is this? So I have given the name of the residential status as location. Okay. So what type of variable is this? Originally it was a categorical variable. It is an alphabetical variable. It is have rural and urban 2 categories. Now we converted it to continuous variable by discrete variable, numerical variable by giving numerical codes. Now it becomes a numeric variable, okay? Because we have assigned the numerical codes to these categories, right? So here, suppose residential status, okay? Now values. Now it is as it is a categorical variables. This function can be used. This is very useful function for categorical variables. Here we can save the codes. We can save the codes. আমি code খিনি ইয়াত save কৰি ৰাখিব পাৰো. Okay. So suppose to save the codes, what we have to do? You have to click it here. Okay. So here this window comes. Here we have to give the value 0, and in label I have to put rural. So add. You see, 0 means rural. Okay, I can specify the numerical codes in this, and it will be very, very helpful. I will show you later why it is very, very important to save the codes. Urban. Okay, this is the code. Then click OK. You see here, it is saved here. No problem. Okay. Now missing, it is not necessary that now. So measure. We have to specify the type of variable here. Click on measure. Right alignment columns. These are things I think you know. No problem. Now measure. In measure, I have to specify the type of the variable. Right. So click on measure. So what type of variable is this? Location. It's a nominal variable. So I have to select nominal. Okay. In rule, you can see we can specify whether this is the independent variable or dependent variable like this. Right. So I have created the second variable. Location. Suppose the location of the first person is rural. So I click 0. You see? 0. Then for second person, it is suppose urban. Then third person, it is 0. Fourth person is 0. Fifth person is 0. Okay. Now you see, I have given the codes here now. I have given the codes here. So if I click on this window here, the codes will appear. So this will reduce the error in data entry. Okay, I am giving this is coming. These are coming because I have specifying the codes here. If I not specify the codes here, then it will come as 0 and 1. So this is a very, very beneficial tool while entering your data. Okay, so then third variable is age of the respondent. So third, I have given variable name is age. Okay, it's a numeric. It's a age of the respondent. Then this is not necessary here because it is not a categorical variable. Here in age, we don't have any categories in any codes. This is the original figures, na? So it is not necessary here. So measure here is scale. Okay, so you see age here. So we put age 23 years, 12 years, like this, 7 years. The first person, this is the first person. This is his area, his location is rural. His age is 23 years. We have to enter our data like this. Okay. Now, suppose I want to put education. I want to make a variable on education. So go to variable view. Suppose education. Okay, so it's a numerical data. I have given numerical codes to them, right? So here, education. I want to explain it here, right? Then what will be the measure of scale here? It's ordinal. It is in a particular order because illiterate, primary, up to SSLC, these are in a particular order. So it is an ordinal variable, right? So you see, so like this, we have to make our database. I will show you my original data. I have, what is our sample size? Our sample size is 300, right? So to open a data, suppose my data are in this in desktop in this folder. Okay, I have kept my data here. So this is the database. This is the file. Here I kept my this. So for that, I have to go to File, Open Data. Okay. Then I have to go to desktop because my data are in desktop. Then webinar Gargaon College. Okay. Open. Then this is my database. Okay. So you see, this is the database. Okay. And this is the variable view. Here, this is the variable view. Here I have given all the codes here, and this is the data view. Okay. It will be look like this. And in this first row, I have all the information about the first individual. In the second row, I have all the information about the second individual. In the third row, I have all the information about the third individual. And in the columns, I have a particular information about a particular one. So this is a basic database. And I have how many individuals? 300 individuals. You see, I have 300 individuals. So like this, you have to make a database like this. Okay. Now, let us go for analyzing the data. So, suppose we have here two types of variable. One is discrete variable, one is continuous variable. I will show you what type of analysis we can do with discrete variable. Can we find mean for the discrete variable, mean of location or mean of education? We cannot find it because they are discrete data. Okay, so what we have to do, what type of analysis, descriptive analysis we can do here? We can make graphs, we can make table for presentation. So suppose I want to make a table for location. How many people are coming from rural area or how many people are coming from urban area? I want to make a table for this. So go to Analyze, Descriptive Statistics, go to Frequency, okay. Then click Location, and this window comes. Okay, here we have all list of all the variables that we have. Then I want to find the table for location. So I have to select the variable location, click this this arrow, then click OK. You see, this is the frequency table for location. So how many people are from rural area? 228 people are from rural area. That means out of every 100 people, 76 people are from the rural area, and 24 people are urban area. Percentage is a very, very important measure for doing statistics. While giving interpretation about this, if time permits, I will show you why percentage is so important. Okay, so you can suppose we have number of categorical variables, a number of variables. Suppose location, sex, education, type of work, family history. These are all categorical variables. Suppose I want to make graphs for all the variable in a single stroke. So I have to go to Analyze, Descriptive Statistics, Frequency, and select all the categorical variables. Location, sex, education, type of work, family history. So it will make frequency table for all of them in a single stroke. You see? And you see here rural, urban like this. If why this rural and urban is coming? Because I am specifying the values in the variable view. If I not given the if I have given, you see, this is coming because in variable view I have given these codes. 0 is equal to rural, 1 equal to urban. That's why this is coming. Otherwise, it will not appear like this. Okay. So you see, it's very easy. It will take very less time to calculate the frequency tables. We can make graphs also. So go to graphs. Here we can make a pie graph or bar graph. So go to graph, simple. Okay. Then suppose location, for location, select this and give category X. So by using pie graph or bar graph, we can make it very easily. Okay, it will come. I think it is slow because of this. It's not coming. I'll show you. Now for continuous variable, what analysis we can, what type of descriptive analysis we can do? For continuous variable? For continuous variable, we can find the mean, median, mode, standard deviation, variance, covariance like this. Suppose I want to find the mean age of the people and its standard deviation. So for that, I have to go to analyze, descriptive statistics, frequency, okay, then okay, so for age, I have to select age, click this, and go to statistic. Okay, go to statistics, click on mean, median, mode, standard deviation, whatever you need. Standard error, range, skewness, kurtosis, quartiles. Okay, continue. So you see, so this is the graph. This appear. This is the graph. This is the UL. This is our. Okay, and this is the all the descriptive statistics for the variable mean. So this is mean is 40, mean age is 40.99 years, standard deviation of mean is 0.96, median is 38, mode is 80, standard deviation is this, skewness is this, kurtosis is this, like this. Okay. Suppose I want to find the mean, median, mode for all the continuous variable. I have a number of continuous variable here. No? So click on this, descriptive statistics, frequency, click age, then height, weight, systolic blood pressure, diastolic blood pressure. These are all continuous variables. So we can make calculate mean, median, mode here. So you see, we got all the characteristics of all the variables: mean, standard deviation, median, mode, all the variables here. It's very easy. It will take very less time. If you are going to calculate it with hands, it will take a lot of time. But it is now very easy. Okay. Now I'll show you one more time. I'm going very fast because time is not there. That's why. Go to analyze, descriptive statistics, frequency. Okay. Then I have to select all the interested variable. Okay. Select here. If I want to remove some variable, I have to select this. Suppose I want to remove age. So I have to click on here, click this arrow. Okay. Then go to statistics. Then select all the descriptive statistics measure. All the descriptive statistics measure are available here. So select one by one. Then click continue. Click OK. Okay. Suppose this is the mean of mean. Okay. I will show you one thing. Suppose I want to find the mean of age. Mean of age. Okay. So mean of age is 40.996, right? Now suppose I want this mean consists of 300 individuals. So sample size is how much? 300. It consists of male and female both. Suppose I want to find the mean age of male only, not females. Okay. Suppose I want to find, you understand for the point? Then I want to find the mean of males only. I want to ignore the females. So for that, what I have to do, there are different ways. So for that, there is an option in data with the help of which we can calculate the mean for a particular group. Okay. Suppose I want to find the mean age of males. So I have to go to data. There is an option called select cases. This option is very, very important while analyzing your data. Okay. These are some method of editing of data. Okay. So you see select cases. Now you see here all cases are selected, right? You see here all cases are selected. This window is open. All cases are selected. Now I want to put a condition here. I want to select only males, right? So if condition set, I have to click on here. If condition satisfied. If I select this option, only those persons will be selected which satisfies our condition, right? So click if. Okay. So I'll show you that. Yes, you go to analyze. Sorry, go to data, select cases. Okay, then now all cases are selected. Now I want to put a condition here. So click on if condition satisfied. Click if. Now I want to here we have to put the condition. Here we have to put the condition. Okay, so I will select. So I want to select only the males. So put select sex here, and males means I think 0. So equal to 0. Now I say that select only those cases which have sex is 0. Okay, so click continue. Click OK. You see, the first person is a female, so it is out of the analysis. Now only the males are selected. Okay, now if I calculate the mean, then only males will be selected. You see now. You see now the total number of cases is 142 only. That means how many males are there? 142. And his age is, mean age is 42 years. Okay. Now I want to calculate the mean age for females. Then I have to go to data, select cases, and all conditions satisfied. Now I have to put it 1. Means select only females. 1 means females. So continue. Okay. Then go to analyze. Now only females are selected, males are out of the analysis. You see it is cut here. Then go to analyze, descriptive statistics, frequency. Then if you find sex, you see there are 158 females, and the mean age of females is 39.99 years. Okay. Now, actually, time is already over. So I want to finish after showing one more thing of editing, how to edit the data. Okay, that is mostly applied while you analyze your data. This is very, very frequently used while analyzing your data. Suppose there is a category here in the blood pressure. A person is called having the disease blood pressure if his systolic blood pressure is this should be 140, right? So if his systolic blood pressure is greater than equal to 140, okay, the person is called hypertensive if his systolic blood pressure is greater than equal to 140. Okay, now suppose somebody asks me how many people are having the disease, how many people are having the disease, how many people are hypertensive. If somebody asks me, so I have to check each and every one. This is 114 less than 140 is not disease person. This is 120 not disease person. This is 111 less than 140. This is also not disease person. Like this, I have to check each and every one. So, but I don't have to. That will be a very lengthy process, now. So what we have to do, I will make one identification variable, okay, with the help of which we can identify which people are hypertensive or which people are not hypertensive. So what we'll do, we converted this continuous variable to a discrete variable having only 2 categories. 0 means no disease, 1 means disease. So I will convert this data. Suppose I want to know how many people are infected from the disease. From that, I have to check each and every variable. So it will be not possible for me if the sample size is very high. So that's why what we'll have to do, I will convert this continuous variable to a discrete variable which have only 2 categories, 0 and 1. 1 means disease person, 0 means non-disease person, right? So how we can do this? So this can be done by using a function called transform. So if you go to transform, there are 2 options are there. One is recode variable, recode into same variable, and recode into different variable. Okay, so recode into same variable, this recode option can be used to convert your data from continuous to discrete variable, right? So suppose I am going to use this function then to recode my systolic blood pressure continuous data to a discrete data. Okay, So let us go to transform. So there are two record options. Which one we have to use? Okay. So first, record into same variable option is used if I use this option, then record will be done on this data. So original data will be gone. Record will be done on these variables. So this becomes 0 because it is normal. This becomes 0. This becomes 0. This becomes 0. And this become 1 because it is 140. 140 or above means that this is. So if I use this record into same variable option, then the original data will be gone and recorded will be done on this here. So recorded will be done on here. Here this data will be gone and record will be done on this. So it will not be good for us because this data may be required in future to do the further analysis. So what we are going to use? We are going to use the transform option in the record into different variables, right? So record into different variable. So if I click record into different variable, so what will happen? If I use this option, then a new variable will be created here. A new variable will be created here. A new variable will be created here, and that will be a discrete variable, right? So let us use this function. Okay, so click on transform, record it to different variable. So here you see in this window we have input variable and output variable. So what will be our input variable? Systolic blood pressure. This is the we are going to record the systolic blood pressure to a discrete variable, right? So click here, click this. So here there is a question mark. So I have to give so a new variable is going to create it now. So I have to give the name of that new variable here. Output variable. I have to give the name of the new variable here. So suppose the name of the new variable is SBP. Click on change. You see it changes, right? And now this is the original variable and new variable will be created. The name of the new variable will be SBP. SBP means systolic blood pressure. Now I have to go to old and new values, right? Old and new values I have to go. So this window comes, right? So this portion is this this portion is for old values and this portion is for new values. You see, so here I have to put the old values, here I have to put the new values, right? Okay, now so old values, so this is a continuous variable, so I have to use the function range. Okay, so click on range. So my range will be like this, my category will be like this. I'll show you. It will be like this. It's coming very slow. So my plan is like this. I'll show you. Suppose 0, if systolic blood pressure is 0 to 139, these people are non-hypertensive because this is the criteria. Na? Greater than equal to 0 is hypertensive. So I will code them as 0, normal. And from 140 and above and more and plus, it will be coded as 1. So this is my idea. So I will convert this continuous variable to a discrete variable like this. From systolic blood pressure 0 to 139, it will be 0. From 140 and above, it will be 1. I think you understand my point. 9. Now you go to SPSS. Okay, so my range will be in all values. My range will be 1, 0, 0. Actually, 0 is not a possible value. 0 cannot be the hypertension, but I'm giving it from 0 to 139. Okay, 0.9. Up to 40, it is up to this level, it is normal. So in new values, I have to put 0. Add. You see, 0 through 139.9, this will be 0. This will be coded as 0. Then 142. So suppose I assume a maximum value is suppose 300. 300. I actually, first of all, I have to check what is the minimum value and maximum value. Okay, I have not seen it. So I assume a maximum value of 300. Okay, so 140 to 300, these are all are called as hypertensive. So put 1 here, click add. So this is my criteria. Then click continue, click OK. You see, this is the variable. Now this person is 140, so it is 1, and this person is 150, it is 1. Others are 0. Okay, so we have to go to variable view and we have to give the codes. You see, 0 means no, and 1 means yes. You see, these are no. Now if I go to analyze descriptive statistics frequency, okay, and put as systolic blood pressure here, I'll know the number of people who are 1 minute. I'll know the number of people who are having the disease. I have to reduce this. These are not meaningful here because this is a discrete variable now. Okay, you see. So how many people are infected from the disease? 33 people. Okay. Okay. So before finishing this, I will show you how to make cross tables. Okay. Cross table is also very, very important. Cross table means contingency table. Okay. It will give lot of information to us. Suppose I want to know the blood pressure pattern among the males and females. Suppose this is the total. Na? Suppose this is the total. This is 33 people are infected from the disease out of 300 people. Suppose I want to know that out of 33, how many people are male and how many people are female. For that, I have to. This is a one-way table. Okay. So for that, I have to make a two-way table. Okay. This is also called contingency table or cross tables. I want to know the breakup of males and female with respect to the systolic blood pressure. Okay. So for that, I have to go to analyze, then descriptive statistics, then cross tabs. Okay, cross tabs, right? And click here. I'll show you one more time. To make cross table, I have to go to analyze, descriptive statistics, cross tabs, right? Then I have to put systolic blood pressure. There are rows. I have to specify the rows and columns because it is a two-way table. It will have rows and column both. In one-way table, we have only rows. Now we have rows and columns both. So I have to do a systolic blood pressure. I have to suppose I am giving in columns and diastolic blood pressure and sex is in rows. Now click OK. This is, you see, this is the breakup. So how many people are infected from the disease? 33 people. Out of that, 22 are male and 11 are females. You see. So I'll show you one more time. Descriptive statistics, cross tabs. So I have to specify the rows and columns here. Analyze, descriptive statistics, cross tabs. I have to specify, suppose I want to find a breakup with respect to location. How many people from the rural area are infected from the disease and how many people from urban area is infected from the disease. Then I have to click here, select columns and click OK. You see, so out of 33 people, 23 people are from the rural area. Out of 33 people, 24 people are from the rural area and 9 people are from urban area. Okay. I think we should stop here because time is also up. Because it's a very long process. I can. Hello.
Yes.
By the
Yes. Correct. No, question answer all of
question. Kiman delay korim moi?
আপুনি আৰু কিমান আৰু 5-10 মিনিট কৰক।
Okay. So I will show you one important thing, the importance of percentage here. Okay. I will show the importance of percentage. Now you see, in rural area, 24 people are infected from the disease, and in urban area, 9 people are infected from the disease. Can you tell me from this table which group is more infected from the disease, rural people or urban people? Can you tell me? In the rural area, there are 24 people, and in urban area, there are 9 people are infected from the disease. Can you tell me which group is more important? Which group are more affected from the disease? Most of you say that rural, because the total figure is 24, and in urban area, total figure is only 9. But you see the totals in rural area. This 24 people is coming from 228 people, and this in urban area, this 9 people is coming from 72 people only. Okay, because it will be difficult for us to tell which group is more infected from the disease, because the total number of people are not same in both the cases, right? The total number is not same, is not it? So we have to make them equal. If we make them equal, then it will be easier for us to tell which group is more infected from the disease. So we can make the both of them equal by using the percentage. Okay, suppose if this is 100 out of 124 people, out of 109 people, then it will be very easy for us to tell that rural people are more infected from the disease. But this 24 is coming from 228 people, and if 9 is coming from 72 people. Both the groups are not same. So from this, it will be difficult for us to tell which group is more infected from the disease, right? So what we have to do, we have to use percentage for this, right? So let us use percentage. So go to analyze, descriptive statistics. The process is same. Go to explore, cross tabs. Click cross tabs. Now we have already this. Then we have to go to sales. Okay, I'll show you the process one more time. Go to analyze, descriptive statistics, cross tabs, right? Click on cross tabs. Then go to sales. To give the percentage, I have to go to sales. Click on sales. You see, here we have the option for percentages. We have row percentage, we have column percentage. We can give any one of them, or we can give both. Let us give row percentage. Okay, so let us give row percentage. Click here, click OK. You see, now percentage is coming. So percentage, we have given row percentage, so percentage is calculated like this way. The percentage is calculated like this, row wise. Row wise percentage is calculated. So there are 100 people. Out of that, 10% people from rural area are infected from the disease. 10%. Okay, and in urban area, there are how many people? 100 people, and how many people are infected from the disease? 12%. From this, it is very clear that more people from the urban area are infected from the disease. If our total figure is same, that means 100. Now, by using percentage, we make both the total numbers is same. It is 100. So now it is very easy for us to calculate the percentages. And now from out of 100 people, there are 10 people or 11 people, more precisely, 11 people are infected from the disease. And in urban area, there are 12 people are infected from the disease. Okay. So it will be very easy for us now to say that urban people are more infected from the disease. Now, I will show you one inferential statistics. Before ending up, I will show one inferential statistic. So, I think most of you heard of chi-square. Chi-square test is used to study the independence of attributes. So, suppose we have two attributes here. There's blood pressure, and here, location. We have two attributes. We are studying two attributes. Two attributes. One is blood pressure. One is location. Now I want to see whether there is any relation between location or systolic blood pressure. Okay. Suppose I want to know whether people from rural area is more infected than people of urban area. I want to check it. So this is called the study of independence. Independence means there is people from both the areas are experiencing the same risks of having the disease. Okay, there is the people from rural area and people from urban area are experiencing the same risks. I want to check it. Now, from this table, it is easy to say that urban people are more infected from the disease. But can we generalize this for the whole population? Because this is true for only 300 individuals. Now, what the observation we are getting, this is true for only 300 individuals. Can we generalize it for the whole population? Now, the objective of statistics is to generalize. Our main purpose is to generalize the thing for the whole population. Okay? Statistics is sir already told you that statistics is the science of decision making under uncertainty. So we have to make decision that whether this is true for the whole population or not. So for that, I have to use statistical test to make the decision, right? So for that, I have to use chi-square test of independence, right? So chi-square test, for that I have to use the null hypothesis. So what will be the null hypothesis? That there is no difference whether a person is coming from rural and urban area, both are experiencing the same risk. Okay, it is null hypothesis is that both the groups are experiencing the same risk. There is no difference. Okay, now for calculating chi-square, I have to go to analyze, descriptive statistics, cross-tabs, then it is already given. Then we have to go to statistics, right? Click on statistics, then I have to click chi-square. I'll show one more time. I think students are already know about chi-square statistics. So go to cross-tabs, descriptive statistics, cross-tabs. This is already we have specified rows and columns. Then I have to go to statistics, then click on chi-square. Now, now this is the chi-square, Pearson chi-square value. Okay, this is the Pearson chi-square value. This is the table. This is the Pearson chi-square value. Here, p-value. This is called p-value. Actually, the students who are in PG or undergraduate, they use tables, statistical tables to test the significance. But nowadays, we use p-values. Actually, softwares give us p-value. With the help of p-value, we can very easily interpret our results. So here, p-value is, I think they are not familiar with p-value, students. P-value is 0.641. It is more than 0.5%. It is more than 0.05. So we accept the null hypothesis. This is accepted. This null hypothesis is accepted. What is our null hypothesis? Our null hypothesis is that there is no significant difference between hypertension between male and female. Both groups are same. So this is accepted here. That means rural people and urban people are experiencing the same risks of developing hypertension. Okay. I think we should finish here. Baido.
Sir.
Barnali.
Hello, sir. Hello, sir.
Yes, Pua.
Sir, finish korbo bicharise?
Time to hoy gol je moi ki korim koi thikile to bahut koi thibo.
Thik ase sir, finish korbo pare.
So thank you. Kiba question ase jodi? If you have any questions.
For questions, we are asking them to put in the sub box, so you can finish it now.
Okay, thank you, madam. Thank you. Question to kenake sam?
Question ami pothai dim.
Hai.
Question ami pothai dim jodi ase.
Thank you one more time, Ranjana Baido and Barnali, for giving us the opportunity to speak. I think not all, but someone may be benefited. Then I will be happy. Okay, thank you.
Thank you, Dr. Manaspratim Barman, for your beautiful deliberation on the using SPSS for data-driven research in statistics and in social sciences. Thank you very much, Dr. Barman. Now, I'm going to conclude this webinar on statistics and data analysis. And before that, Professor JITEN Hazarika will be online to answer the questions put by the participants. Hazarika sir, are you online?
Sound দেখা নাই নহয়, ফোন কৰি দিছো ৰব।
হয়তো তেওঁ লাইনতে আছে, খালি অডিওটো মিউট হৈ আছে, মই আনমিউট কৰি দিছো।
বৰ্ণালী, তুমি ছাৰক ইনফৰ্ম কৰাচোন। Good afternoon, Hazarika sir.
Yes, are you hearing?
Yes, yes, sir. I request you to give the answers of the questions put by the participants.
Okay, okay. I will move quickly. Pragyan Madhav Bora, use of statistics in civil services. Actually, statistics is, I have already told, where is no statistics. Without data, a civil servant cannot move. They have to take some special type of data. For example, I want to give one example. That is called a respondent-driven sample. It is very much important in case of civil, because from one respondent to they have to move by system. This is one of the example. And basic statistics also are the requirements of that to take decision. If it is in a magistrate or some other person, that crime statistics is very much essential. And you know, perhaps one of our that is now his PhD work on crime statistics, using crime statistics. So it is always essential. Next, Amal Bhomik asks about the probability and statistics relations. Actually, whole statistics is based on probability, and some social sciences may not know probability, but they are unknowingly using probability, because all tests of significance are based on probability. That derivations are based on from some sampling distribution. That sampling distribution is based on only probability. Because I have already told in the definition, that is, where there is uncertainty, statistics is there. So we are going to minimize the uncertainty. Uncertainty means probability. Jor onishchayata thakibo, tar sambhavana thakibo. Onishchayata thakile sambhavana thakibo. Next, another question is Himanshu Bora, alternative statistics. I think he is going to point that out, that big data analysis and that software development and some that is artificial network. He is going to point out these things. Due to this, statistics may not be necessary as an alternative we can use. But without knowing statistics, without using tools, no artificial data analysis. Everything is based on statistics. So from my point of view, we cannot think of alternative to statistics at present, at least. Now, another question is, one participant is interested to know about the Dharmendranath ISI Tezpur. In ISI Tezpur, actually, one diploma course is there, that is postgraduate diploma in statistical methods and analysis. For that, graduate with mathematics is the requirement. BTech can also course, and any other equivalent qualification like AMI or some other qualification. It may be major in statistics with mathematics subject, and good academic records, tests, an interview should be there. So people they have so far they have appointed, TCS has appointed all the persons, those who successfully completed the postgraduate diploma in statistical methods and analysis from ISI Tezpur. So you can visit the website of Tezpur University ISI. And another question is regarding the research questions and hypothesis from SK Hazarika. Actually, research question and hypothesis, we can say as same, but we can combine 2 or 3 research questions in a single hypothesis in statistical sense. In statistics, we can combine. We can combine because in a same hypothesis may come both the research questions. But you are correct. Almost similarity is there, research questions and hypothesis. Only the writing style is different. That like there is no difference. It is dot by dot we stop it. But in case of research question, we make questions like that. Which one is greater, which one is less? We do not take, but we take no difference. Like, and regarding sample size, it is actually millionary question. Sample size, it is debating. It is a debate of our statistics among our statisticians also really sample size. But for your information, it is not based on population size. It is based on variation in data. So why I have mentioned as PC Mahalnavis used that first we need pilot survey. Based on pilot survey, we can calculate variability in the data. Variability means with the help of standard error or something, we can calculate. And sometimes we can use earlier studies, some figures also. So many sampling size formulas are there. Based on objectives, we can use sample size observation, sample size, we can determine sample size. But as you have pointed out, population size is large, sample size is large. Population size is small, sample size is small. This is not true. Sometimes sample size may be large, population size may be small compared to the earlier one. And if population size is large, sample size may be small if there is homogeneity, if data are homogeneous. So this is a large topic. It is not possible to answer all the things now. That is sample size determination may be one of the webinar seminar. Like categorical data analysis may be one of the seminar. And anyway, thank you, Hazarika. Then pool data. One person, Olympia Setia, I think, Setia or Setia, she pointed out that it is a combination of time series and cross-sectional data. Yes, correct. It is a combination, but instead of this is just name, and that is pool data. It is a short form. If you write combination of time series and cross-sectional data, it is a lengthy one. Now, how to deal with probability? Please help. Rani Khatun has written, okay, you come with to our department. I don't know from where you are, but your participant, and I will ask Bornali. But you can come. You can come to our department. We are here. Not only me, Dr. Manaputi Morwan and other senior and junior young teachers are here. You can discuss with us how to deal with probabilities. Yes. Actually, কিছুমান ক্ষেত্ৰত কি কৰা হয়, আমি probability বুলি ভয় খাই দিয়া হয়। এই statistical probability টো এটা বৰ বেয়া বস্তু, বৰ ভয় লগা বস্তু। এটা ভয় খাই দিয়া হয়। কিন্তু সেইটো আসলতে কথা নহয়। আৰু probability নহলে কিন্তু statistics সম্ভৱ নহয়। সেইটো এটা কথা। আমি ইউজ কৰিব পাৰিম। কিন্তু আন সাবজেক্টে পাৰিব কাৰণ আমি এতিয়া টুল হিচাপে ব্যৱহাৰ কৰিব। They are using as tools. তেওঁলোকে পাৰিব। কিন্তু being a statistician, we should know what is probability. আমি জনাটো উচিত। Then, last but not least, Dr. Rubab Namani, she is from Kanoi College, assistant professor from Kanoi College. Actually, he did already PhD degree. And second query I am going to address first. That is, see, without using residual analysis, he completed PhD work, if particularly you have used regression models, yes, residual analysis is necessary, because otherwise misleading conclusion may come. If already you have got the PhD degree, your conclusion is okay, then, or you can nullify your conclusion also as a further research. You come always with you, and always with this, we are discussing with you. You are like my sister, no problem. You can go ahead. You can take your problem again or residual analysis part. You can do, no problem. Another question is the effect of higher, that example I have given in the regression. This is the last question. The effect of higher correlation consumption raising average temperature could be true over the long run. No, it is not correct, because I am going to say about the cause and effect. For predictive purpose, it is correct. You can predict. You can predict using one variable, other variable. You can predict. I am not going to say about predict. I am going to say cause and effect. One is the cause of the others. No, it is not possible. So if cause and effect, then you can control. You can control. You cannot use the control variable here as other one as response variable. Or cause and effect, you cannot use. In long term also, it is not possible. For predictive purpose, you can use, no problem. With the help of one variable, you can predict the other. That is correct. I have pointed out cause effect of medical science. If we are misuse of statistics, if we are going to make it cause and effect one, then it will create problem to us. So I think these are the answers. Internet connection is also poor. If you are hearing or not, I am sure. Are you hearing in the last question answer?
You can continue.
Audible. Last
Yes,
question
sir, you can
also.
Continue.
I have to get more actually. So in long run also you cannot use as a cause effect relationship. For predictive purpose you can use. These are questions only, not tough questions for me. I am expecting some tough questions so that I can answer later on. But anyway, I again offer my thanks to the college authority as well as our Dr. Ranjana Gogoi, Head Department of and Bornali Dr. coordinator of this program. Thank you again.
Professor Hazarika.
Yes.
Thank you very much, Professor Hazarika, for your answers to the questions put by the participant. Thank you very much. Now I am going to conclude this webinar, and I, on behalf of Department of Statistics and Organizing Committee of this webinar,
Any question or other part, no question. Other part, no question.
No,
regarding,
sir. No, sir.
Dr. Barman, no question.
Yes, no question. Yes. No questions from Dr. Barman's deliberation.
Okay. You can go ahead.
Thank you, sir. Now I'm going to conclude the seminar. I, on behalf of Department of Statistics, Gargaon College, and the organizing committee of this webinar on statistics and data analysis, offer our sincere gratitude and thankfulness to the Honorable Principal Gargaon College for his encouragement and full support in organizing this webinar. My sincere gratitude and thankfulness to respected Professor JITEN Hazarika, Head of the Department of Statistics, DIBRUGARH University, and Dr. BARMAN, Associate Professor of Statistics, DIBRUGARH University, for their thoughtful, informative, and excellent deliberation, and I think which will be helpful for most of the participants in their academic research. My sincere gratitude to all of the participants, without whom this webinar may not be a grand success. I must offer my sincere thankfulness and gratitude to Dr. Surajit Saikia, Assistant Professor of Economics, Gargaon College, for whom we will be able to organize this meeting online in Zoom and live streaming at YouTube. Dr. Saikia has provided us this webinar platform from his major research project grant. Thank you, Dr. Saikia, once again. And once again, I thank you, all of you, and I announce that the webinar on statistics and data analysis